I want to raise it. I want to raise it for my height, but everybody else would be like, Joe, are we good? Joe? We're good? Okay. Good morning. Welcome to Floundering Around. We're having a short couple days to talk about everything we don't know and think we know about flounder in Gulf and South Atlantic. I'm Steve Erik with the Gulf States Marine Fisheries Commission. We do a lot of fisheries management plans, profiles. We coordinate a lot of the work that goes on in the Gulf. States do the effort, and we get the credit of sort of collaborating, pulling it together. You good? Okay. Anyway, we started wanting to put this together a couple of years ago, and then this kind of a weird virusy thing started, and it kind of delayed things. In that time, we realized that Sea Grant and LSU were interested in doing something similar. So we collaborated, we pulled our resources together, and once we started to get travel, we went ahead and brought y'all here. So everybody will get a chance to meet everybody. We have a luncheon at noon. It'll be in the atrium area where breakfast was served. It's provided. If you've registered, we know you're coming, you've got a head count. If you need anything during the conference, just reach out to any of us in the back. Joe is our IT guy. He's running IT guy. He's our network man at the commission. He's running the show here. If you need anything, if there's any problems, if you have slides you need to have in your presentation changed or anything, he's the guy to see. Debbie McIntyre is out in the lobby right now doing registration. She's assistant. And I'm Steve if you need anything. A couple of basic housekeeping things. Let's see. If you didn't register, please do so that we do have a record. We don't mind people walking in and just coming, but we'd like to at least get a record of you. This is a YouTube stream. We are currently live. You're being broadcast to the world. It'll be broadcast in 4 sessions. So the morning session until after lunch is one, and then this afternoon is a second, tomorrow morning. Are we good? And then the final wrap up tomorrow afternoon. So there's 4 links. You'll be able to access them after the conference. They'll live there hopefully forever. Nothing comes off the internet. Remember that, kids. If you have questions, we have a roaming mic, a couple of them. We just ask that you give your name and affiliation, not only for our record, but also for the people on the live stream so that we know who's talking. Just kind of, that way we keep the references of who's who. We will have a breakout session tomorrow afternoon during the afternoon session, and the broadcast will continue, but it will not be something that's actually broadcast. When we come back together as a group, that part will be picked up and continued online. During each break, the presenters for the next block, we ask that you come up here and meet with Joe, get a rundown on how things are going to work with the remote and AV equipment. So on each break, if you're up next in the list, come up here and meet with Joe. Is there anything else? I think that's it. Okay, I appreciate everybody coming. I was a little nervous about getting up here after watching the Oscars, so I have a bad sense of humor, and I was nervous. So Steve and Mike, give you all the floor, and I'm going to be back there. I'm going to be waving at the presenters when they've gone about 13 minutes of their 15, and then at 15 minutes we hope to stop and have Q&A, and then another 5. If we get ahead of schedule, we're going to wait to start the next round. If we get behind schedule, I'm in trouble. So I guess that's it.
You select me or do I select you?
Whatever you want to do.
All right, too soon. Too soon. All right, yeah, thanks again to Steve. My name is Steve Midway. I'm at LSU, and I'm sort of the co-program chair along with Dr. Mike Dance here. We're really happy to see everybody, and I don't have a whole lot to say because I know we all want to get started. I wanted to just give a quick rundown of who's here. This is a quick little bar chart of the registrants to this symposium. Obviously, a little home field advantage going on, but otherwise very well represented. We're really happy to see this much interest and this much, people willing to put out the effort and travel to come and participate. And then if you're curious about the units that are being represented here, you probably can identify yours. Apologies if I didn't select the official logo. But that is who we are in this room, concerned about flounder, thinking about flounder, wanting to talk to each other about flounder. So we're very appreciative of that. And then finally, as Steve mentioned, just to give you guys a quick rundown, today we're going to cover 1 and 2, which is the life history and pop dye session in the morning. That'll trickle into the afternoon a little bit, and then we'll get into the aquaculture and genetics session. That'll be followed by the poster session as well, so there's sort of a second part to that. And then tomorrow morning we start with movement and migration in the morning. We end with the synthesis session, and there'll be a little bit more information on that forthcoming, but we're going to have small groups that people will sort of self-identify and move into. We'll have some prompts for discussion, and then we're going to return to the large group, at which point both everyone is welcome to share and discuss their thoughts, but we would also hope to have sort of representative comments from those small groups to talk about sort of next steps for this. The only other thing I'll mention is that I've talked to a number of people and mentioned it. We're hoping to get something out of this symposium in terms of a review paper, white paper. I don't know what exactly that is, but everyone who registered will be followed up with once that sort of comes into focus. If you have thoughts or ideas, or there's something that you can get out of this that the larger group can help with, please let us know. Otherwise, again, enjoy, ask questions, and hopefully we'll learn something. The first speaker this morning is Dr. Fred Scharf, who's going to be talking about key aspects of Southern Flounder life history, knowledge gaps, and potential effects on stock dynamics. So, the floor is yours, Fred.
That does work, okay. Thanks to Steve and Mike and Steve for putting this together. I thought it was a great idea, and really looking forward to having the chance to talk to people, hear about what's happening, especially in the other basin. And before I get started with some of the science, I just wanted to acknowledge some folks. Hoping this is working. Maybe not. There we go. Did you do that, or did I do it? Okay, I'll keep trying. So just wanted to acknowledge a lot of students and collaborators. You'll even see Steve Midway up there as a former PhD student in my lab, but lots of different students that contributed to some of the work that I'm gonna touch on, as well as lots of collaborators. Okay. So just to orient you a little bit to the species range, most of what I'm going to talk about has been informed by work that has occurred in the South Atlantic. I have sprinkled in some Gulf of Mexico stuff, but most of it's going to be focused on work that's happened in the South Atlantic, particularly stuff over the last 10 to 15 years or so, but also some historic work. Now, I don't need to go into detail too much about flounder life history with this crowd, but just that we know that we have an offshore oceanic spawning of adults. We have some advection and larval movement into the estuarine waters, settlement in a variety of habitats, growth and maturity up to 2 or 3 years, and then eventually emigration from those estuaries and movement out to the ocean. And what my goal was here for this talk was to really kind of move through that life history ontogenetically and talk about what we know about certain aspects of this life history and then highlight where I think some of the gaps are. And I wanted to start by first talking about some of these offshore spawning locations. There's a lot of text up here, but one of the things that you can see is these are some ichthyoplankton surveys. These are all in the South Atlantic, right? And the first thing that you can see is they're old. So most of these are old surveys from the 60s and 70s, right? Just sort of reflects a time when the U.S. invested a lot more in egg and larval surveys relative to what we do now. But also, you can see that we refer to many of the flounder as Paralichthys species. So for many of these surveys, only dentatus was described clearly, and they grouped lethostigma and albigutta, the Gulf and Southern Flounder. But the main takeaway from this is that these ichthyoplankton surveys, while they weren't targeted for Southern Flounder, they did pick up Southern Flounder as part of some of these surveys, and you see that the collections of the larval stages and the egg stages are out near the shelf break, generally the outer or just near the shelf break, and that those collections peaked in the winter months, typically in January and February, anywhere from December to March. The other information that we have that informs offshore spawning location, at least in the South Atlantic, were two really extensive diving surveys, scuba surveys, one that took place in the early 2000s off the North Carolina coast up here, and the other that took place about 5 years later off the South Carolina coast, off of Charleston down here. Now, both of these surveys were limited to depths that were scuba depths, so generally 130, 140 feet. And in the North Carolina survey, for instance, they did observe fish sort of staging on the shoals and moving deeper as the fall and progressed into the early winter. But what's notable is the complete absence of southern flounder in the South Carolina survey in the winter, and the only small presence of southern flounder in North Carolina in the winter. So what we inferred from these diving surveys is that the flounder weren't in these near-shore habitats, near-shore shelf habitats that were diveable. Okay. So between the ichthyoplankton survey, which is a bit interspersed, and the lack of flounder in the inshore diving surveys, we basically still have this uncertainty about the offshore spawning locations. And I know tomorrow in the movement talks that Shelby and Caitlin are going to be talking a little bit about some new efforts in North Carolina to look at these offshore spawning locations. In terms of the transport of larvae and recruitment into the estuaries, Chris Taylor published a couple papers about a decade ago, and one of them focused on the effects of some oceanographic processes and environmental correlates, and they found a pretty strong relationship with late winter, early spring winds that had an eastern component and juvenile CPUE. So those are here on the bottom. So if the winds had an east component, whether from the north or from the south, they saw strong juvenile recruitment in the estuaries. They also compared the larval survey at the inlets with the juvenile abundance in the estuaries and found that that was also really strongly correlated, which suggests that between that February and March larval ingress peak and the juvenile survey in May and June, that there wasn't any evidence for really strong density dependence. The other thing that we see in terms of juvenile settlement, and a lot of this in North Carolina comes from work that Burke did, is that we see settlement concentrated in the upper parts of the estuaries in these oligohaline habitats and low salinity habitats. And some of the recent work we've done has corroborated this concentration, although we do see a diversity of settlement habitats. We see fish settling in the mesohaline as well. But the long-held view was settlement in the oligohaline and then shifting into the mesohaline as the juvenile stage progressed. There's also been shown some potential for low salinity contingents. And this is some work that came from the Gulf of Mexico, Ben Walter and Troy Farmer's work. Also, a master's thesis out of ECU showed some evidence of this in North Carolina, where you see the presence of oligohaline signatures throughout the life history of some individuals, so that there may be some of these these freshwater contingents, fish that never move into the mesohaline and spend all of their nursery period in the upper waters of the estuary. We think that this could potentially have some implications. You know, we've been doing some work on juvenile settlement habitat effects more recently, and it stemmed off some work that Gary Fitzhugh did in North Carolina in the early 90s. And he found this really strong bimodal pattern of size and growth in the early life history that was not related to sex. He saw a lot of variation just within the females, even after they had differentiated into females. He saw this bimodal growth pattern. And we hypothesized that it could be related to settlement habitat. In particular, low growth in the oligohaline habitats, and whether that's compounded by some osmoregulatory costs of being in these low salinity habitats. But it appears to also cause a delayed shift in piscivory. And so what you see is fish, this is just densities of sizes in different habitats during the late spring through the early summer. And you see in the green, in the mesohaline, you see the larger fish and a more dispersed growth pattern than we see in the oligohaline habitats. And so when we combine all this information, what I've sort of inferred is that the juvenile recruitment patterns tend to be linked to some local oceanographic conditions, particularly the wind patterns. But one thing that we really don't know much about is the conditions for successful hatching and larval survival in the ocean. So particularly temperature conditions that may promote survival and hatching, which may be linked to some of the recruitment patterns that we're seeing in the Gulf and in the South Atlantic. We also don't really have a good understanding of the implications for the dynamics of the population of these freshwater contingents, how they contribute and what their contributions are to the stock. As we move into the older ages in the estuary, one of the first things that we did looking at life history traits was some of Steve's dissertation work was looking at the maturity schedule. And one of the things that he found was that using histological approaches, found that the maturity schedule shifted to a larger size at maturity, an L50 closer to 16 inches in North Carolina as opposed to 14, which was what was presumed at the time, and also a bit of a shallower, more gradual change to maturity. And this had some important implications in terms of the proportion of fish mature at each age. And it also had some implications for spawning stock biomass and biological reference points. So the new maturity schedule, in order to achieve 40% SPR, the Fs had to be much lower, okay, based on that. So the take-home was that the maturity schedules in North Carolina appeared to be shifted a bit later, and there's been some new evidence, one of Nancy's students in Mississippi, and also some anecdotal evidence that we have from Florida that suggests that there may be a latitudinal gradient in terms of size and age at maturity, where we see younger size and age at maturity in the southern part of the range, and then shifted to a bit later when we get up toward North Carolina at the upper part of the range. There's also some evidence in Florida that we found that it appeared to be less size dependent entirely. I can talk to folks about that if they're interested. And then I think Steve's going to talk a little bit later too in terms of just spatial variation in life history traits, particularly growth, and potentially natural mortality. Speaking of natural mortality, we were interested then in sort of looking at fates of individual fish during their time in the estuarine nursery from age 0 to age 2 or 3 when they leave to mature. And we did an extensive study in North Carolina in one of the coastal river systems where we tracked 3 cohorts. We did this through acoustic tracking. You can see the network of, let's go backwards, the network of receivers in this system over here. And we combined that with conventional tagging at a statewide spatial scale. So we had 2 spatial scales to inform mortality as well as emigration. And we applied this using a multi-state capture-recapture model where we did some double tagging, high reward tags, and we assumed 100% detection of harvest and emigration through these high reward tags and the networks of receivers that we had. And this model allowed us to estimate independently instantaneous rates of fishing and natural mortality, as well as emigration. And when we did this at different spatial scales, what we saw is that the best model supported a constant rate of natural mortality over time, as well as a constant rate of emigration over time, and then variable rates of fishing mortality that were dependent on the scale, whether we were at the state scale or whether we were at the individual estuarine scale. And so the take-home was that the emigration accounted for a large fraction of the estimated loss rates from the estuary, and the total loss rates lined up really nicely with estimates of loss from catch curve from the survey data that was happening in the state. What's less certain are the sources and the size dependence of natural mortality. Those estimates of natural mortality are very early in sort of age 1 fish, so fish in this size range or so, and they line up pretty closely with the estimates of natural mortality from some of the life history-based models for that particular age and size, right? So understanding some of the sources of mortality, not just the magnitude, but then the size dependence and how that varies spatially is going to be a key to understanding stock dynamics of southern flounder. Last thing was really talking about the extent and spatial scale of stock mixing. And we focused this on the South Atlantic, our studies, and this was informed from several sources. And the first was a suite of conventional tagging data that we had, some historical conventional tagging data in North Carolina, as well as some more contemporary. And the big takeaway from this is that we see all of the long-distance movements from North Carolina occurred in a southerly direction. So fish that were tagged and released anywhere in North Carolina, if they moved more than 50 kilometers, they were always to the south, as far down as sort of the east central coast of Florida. We also looked at morphometrics, both whole body and otolith morphometrics, to look at stock structure in the South Atlantic, and found a high level of mixing. Very difficult to discriminate individuals based just on those morphological traits. And genetic work, right? So both some AFLP work as well as mitochondrial work. And what you see is clear separation here. The Gulf individuals are up here, Gulf of Mexico, and the Atlantic are here. And within this Atlantic, you see lots of different colors. So there was some evidence of structuring in the Atlantic, but it wasn't aligned geographically. And then lastly, to inform this, we looked at otolith microchemistry. So we built a juvenile atlas of fish that we collected in the different states and looked at this sort of pre-migration nursery signal. And then we collected adults that were 3 or 4 years old, and we looked at that juvenile signature to see if we could assign those adults back to those nursery habitats. And what we found was that the nursery origins were really mixed, and that fish adults that we captured in North Carolina basically came equally from all 3 of those states that we had the juvenile atlas for, and the same in South Carolina. And the message was that we assumed that this was at least partially driven by some post-spawning movements of adults. And this had some implications because one of the reasons for those dive surveys, particularly the one in North Carolina, was related to the fact that these guys may stay offshore for long periods of time. And so this had some implications about whether fish stayed offshore and how it affects stock biomass, and whether, because the assumption is when they're offshore, they're not exposed to any of the inshore harvest pressure. And so we found that basically in order to, at moderate levels of F, right, we could have a lot of the adult stock exposed to harvest. But if the F was really high at heavy exploitation, we needed that stock to be almost fully cryptic to harvest mortality. So the cumulative evidence indicated extensive broad-scale mixing, and that the post-spawning movements of adults and habitat use still remain highly uncertain. And so to conclude, what you see up here is basically those 6 conclusions from the previous sort of green boxes that showed up. Oops, I think I just shut this off. There we go. And so I'll let you look at those and be happy to try to take any questions.
Thank you, Fred. We've got a microphone. If anybody has questions they want to ask, I can bring it around.
Hey, I'm Henry Hershey from Auburn University. My question was about, you mentioned that there was some evidence of structuring in the Atlantic coast, but it wasn't spatially linked. Can you explain that a little bit more?
There was a little bit of substructure in the mitochondrial DNA, but the units that were more closely aligned weren't close together. So in other words, we thought there'd be some sort of closer association genetically with distance, and it didn't align that way. So there were some fish that were genetically distinct from each other within the South Atlantic, but it may have been fish that were almost really close together, and then fish that were similar genetically in the Atlantic were really far apart. So it was really difficult to disentangle that within the Atlantic. It's early.
Up in the corner. Hang on. I'm coming.
David Norris from Louisiana Wildlife and Fisheries. I was just wondering on the juvenile mortality studies, is there any investigation or reason to investigate how they might compete with other flatfishes? Because just anecdotally, it seems like we catch a lot of small flatfish, but very few of them are actually flounder.
So other flatfish within the estuary in the nursery grounds?
Yes, sir.
Yeah, no, that's an interesting idea. We hadn't really explored that. You know, we do see there are some other flatfish species that we see in those same estuarine surveys. And it would be interesting, I think, to look and see whether or not, you know, the catch rates of some of those other flatfish species have increased while we're seeing declines in southern flounder in the juvenile nurseries. But I don't know that anybody's looked at that, not that I'm aware of, but it'd be interesting to look at. Hey, Troy. He's got a mic for you.
Troy Farmer from Clemson. Really neat results for the natural mortality, and combined with growth, with seeing slower growth in those oligohaline habitats. In your natural mortality study, is there a potential to look at mortality in different areas of the estuary to understand if that slower growth may be leading to higher survival in the upper oligohaline portions?
Yeah, in fact, that work was actually part of Spencer Gardner's master's work, and he was actually planning to do a tethering study and look at sort of mortality, because these were the little guys that he was looking at, was sort of this early post-settlement up to maybe 6 inches or so in the early summer. And so he was going to look at just relative predation potential in different parts of the estuary. And he has some data from some of the surveys that indicate predator abundance in the mesohaline, but and it certainly would indicate that low salinity area may be a predation refuge. So there may be a growth mortality trade-off happening, which is what allows those low salinity contingents to persist, right, and contribute to stock dynamics, because while they sacrifice a little growth, delayed shift to piscivory, there's also not as many things up there that can eat them. Yeah.
Great, thanks.
You got one more. Okay.
Yes, Dr. Scharf, how are you doing this morning? My name is Paul McLaughlin. I work at the Lake Charles office for Louisiana Department of Wildlife and Fisheries. I work out of CSA 7. And you had mentioned that you noticed that there may be some latitudinal difference in terms of overall growth rates for fish from the different nursery areas. I was wondering, when you looked at the different the different potential nursery areas, did you notice any latitudinal bias towards male and female origin from your surveys? Did you notice any difference? Like, did the lower latitudes tend to produce more female fish versus the higher latitudes? Did you notice any sort of shift like that?
Oh, that's a good question. No, I don't. It's not something that we've looked at in terms of sex ratios by latitude. I know that John and Russ are going to talk a bit about sex ratios in their response to temperature in terms of that juvenile settlement habitat. But it would be interesting to look, more comprehensively at sex ratio across different latitudes as you go from North Carolina to Florida to see how they respond. But it isn't something that we've looked at.
Thanks, Fred. Some good news and bad news. Bad news first, Dr. Darden, who's giving the next talk, or was authoring the next talk, was unable to make it. So graciously, Aaron Watson has stepped in, and he'll be speaking next. Thank you, Aaron. All right, good morning, everyone. I'm Dr. Aaron Watson from South Carolina Department of Natural Resources. So I am none of these people up here. Joey is at a Red Drum stock synthesis review in Raleigh. Morgan and Katie were graduate students and then full-time biologists in the section who have since left the section. And as you just heard, Tanya, who is our institute director and former director of our population genetics group, was unable to travel this week. So you're stuck with me trying to work our way through this presentation. I am the manager of our mariculture section, so as you'll hear later today, we are beginning to spin up a Southern Flounder stock enhancement program. Our inshore fisheries section, which is where the bulk of this data comes from, mariculture section, and population genetics group, all work together on our stock enhancement program. I'll talk more about that this afternoon, but hopefully we can get through this movement and maturity in South Carolina Southern Flounder presentation. Plays on a lot of what you just heard, actually, which is a good thing. So understanding stock status, this should not be a surprise for anybody in this room. But critical elements include life history as well as stock connectivity, whether it's a single stock or multiple stocks. Critical things to understand. And I am going to have to step away a little bit to see my slides, but that's okay. So there's potential for dramatic changes in population stock status with tiny little changes in any of these reproductive characteristics or movement patterns. And then the Atlantic Southern Flounder has been assessed as a single unit stock, at least currently. That's how it's treated. All right, thank you. Much better. So sexually mature flounder are believed to move out of the estuaries into offshore waters to spawn in the fall through the winter, as we just heard. So some of the objectives I have for this presentation are to go over some of the South Carolina surveys, updates to South Carolina abundance data trends, summary of our South Carolina tagging studies that have been conducted over the past few years, and then a size and maturity analysis in South Carolina that is the same but different from the one you just saw. So our South Carolina inshore surveys primarily that target flounder or recruit flounder is our electrofishing survey, which is conducted here in yellow color in 5 of our estuary systems, or upper estuaries. And it's considered a recruitment index for southern flounder, has been conducted monthly since 2001, and they do about 300 collections per year. And then our channel net survey, which is in the red areas, more of the marsh or estuary proper, is the adult index that we utilize for southern flounder. It's been conducted monthly since 2000, and they do about 1,000 channel net sets per year throughout all those areas. So spatial synchrony and annual relative abundance by strata in the surveys. What we do see is a difference here, with the top left being our electrofishing surveys, and these are the 5 different strata those are collected in that they were highlighted in the previous map. And so between those, you can see on the graphs, they've been 2000 through 2001 data. There's a very tight spatial correlation in the electrofishing survey between estuaries. So the trends in recruitment driven by broad-scale influences, abundance of adults, that sort of thing. When we move to our tramel net survey, this is the adult survey as opposed to the juvenile recruitment index. What we see is less spatial correlation, primarily driven by Port Royal Sound in the southern part of the state, and Winyah Bay, which is the kind of sort of north-central part of the state, having significantly different patterns than our other 3 areas, which look much more similar to our electrofishing recruitment index. So that could be due to differential fishing pressures, water quality, habitat suitability, different pressures on adults versus juveniles and larvae. So combining all those together to look at a statewide relative abundance, we see the same trends generally that a lot of folks are unfortunately familiar with here for southern flounder is a rapidly declining trend both in our trammel net for adults and the electrofishing for the recruitment index. So one of the things that we wanted to do that a lot of other folks have been working on in their states and that sort of thing is look at inshore movement. And so we've conducted 2 studies with these, one with conventional tags and one with acoustic tagging. So our conventional tags, this study was conducted between 2015 and 2018 with multiple estuary releases. 1,175 fish were tagged. You'll see that we've had 32 recaptures. However, 81% of those recaptures were tagged and recaptured in the same estuary. So seeing some limited movement with those limited recaptured numbers. Again, we see limited inshore movement with our acoustic tags. This is a 2015 to 2016 study where all fish were released in the Ashley River, which feeds into the Charleston Harbor, right in the central part of the coast. This is conducted of 118 acoustically tagged fish, 275 millimeters or larger. 96% of those tagged fish were detected in our receiver arrays, and the longest detection we have is right at about the battery life of these little 29 millimeter tags, and you can see there the insertion site for those, 370 days. And so 88% of the fish that were tagged and detected remained within the river of release. So they never left the Ashley River during the time of this project. And on the right side, we can see that the distance moved. So on the bottom, we've got a full calendar year, January 1 to January 1. And these are simply the date of last detection for these animals. This consists of 2 different batches of released fish, where the yellow squares and diamonds were released in the Ashley River. Blue were released in the Charleston Harbor, or detected in the Charleston Harbor, and detected in the Ashley. And then the colored in ones are ones from batch 1 and batch 2 with different shapes that were actually detected offshore. And you can see that our offshore detections occurred in the winter months when you would expect them to, with some larger animals moving offshore. And similar to the previous presentation, the offshore migrations that we have detected acoustically and with conventional tags have all been cellularly. So on the left side here, acoustic tags all released in the Ashley River there in Charleston, and detections, the black symbols are all acoustic receiver arrays, and the red symbols are where fish were detected or last detected. And you can see that we have up to about 263 kilometers of movement, all in the southerly direction. Similarly, with conventional tags, here we've got release sites in diamonds, so we've got a few different release sites spread over the central part of our coast, and then recapture sites are in the circles, where the bigger the circle is, the farther that fish traveled from where it was detected. So all detection, or all releases in diamonds, and then all movement that was detected was in a southerly direction. So size and maturity in South Carolina. So as we just saw, the assessment assumed low stock productivity. They used a large size for female maturity, the 50% maturity at 402 millimeters total length. And then we just heard quite a bit about uncertainty and potential latitudinal variation. I think this is just going to add to that question. In South Carolina, to look at this specifically in our waters, our inshore fisheries group histologically stayed 963 flounder. And you can see the size range there, 159 to 627 millimeters. And developing to actively spawning, so February and then July through December. And you can see with those 963 flounder, our 50% maturity level was 306 millimeters total length, so quite a bit smaller than what was presented just now from North Carolina, and quite a bit smaller than what was used in the assessment. However, if we utilize that same Midway Scharf method and utilize October to December samples, one thing to point out here is that when we remove those immature, or we consider the regenerating flounder as immature, as that assessment did, it drops our numbers from 963 down to 139, and our range in size is 190 to 585 millimeters total length. But when we do that and utilize similar methods, we get a similar size and maturity of 432 millimeters. However, you can see that includes some individuals well above 500 millimeters, which we know doesn't really fit with the rest of their life history characteristics, but we do get that similar curve. So to dive into this a little bit further and look at reproductive stages by total length, so here across the bottom we've got 2 centimeter size bends, and then the frequency of animals for this study. And then If we look at red is our immature, developing is green, regressing, which is there's only a few down here in the tealish color, and then that regenerating in purple. What we see is the mode of distribution for that regenerating much more closely matches our developing animals than it does the mode for our immature animals. And so the question there is, do we have some of that latitudinal variation where the southern flounder in our more southern waters are developing a little bit early with a little bit different pattern? And so what we're considering is adding additional effort to validate this methodology. What's the most appropriate way to histologically stage and include these or exclude these? And then is there a timing of oocyte transition from primary growth to hydrated that may be different latitudinally? So some of the implications that this has raised are that some of the sampling and some of these projects have conducted is they suggest a portion of mature adult female southern flounder are overwintering in estuarine habitats in South Carolina. And although this is a picture of a 552 millimeter total length mature female that was collected in 10-degree water in the winter in our upper estuaries. And this is not the only fish that's been collected that way. So the questions, so it raises quite a few questions. Are the winter or the fall winter temperatures the cue to move offshore? Are there other cues to move offshore where only maybe larger fish are moving offshore? And other environmental cues? Are there skip spawning type mechanisms at play where the fish knows it doesn't have enough stores to make that offshore migration for spawning, and so it skips the season and doesn't leave the estuary? And then some of the other things is that so some females may be spawning inshore without migrating. And instead of movement associated with spawning, a more general movement that's related to larger fish as opposed to all fish moving off that are sexually mature. And so, what we need here is a significantly better understanding of winter inshore habitat use. Uh-oh. There we go. So I would just like to acknowledge all the folks from our South Carolina Department of Natural Resources Inshore Fisheries section. They're the ones who have collected all this data, analyzed this data, especially Dr. Joey Ballinger, and then our funding sources, primarily Daniel Johnson Research Funds, and then the South Carolina Saltwater Recreational Fishing License, our SURFAC funds that support a lot of our inshore mariculture population genetics groups. I talked really fast, so we have a lot of time for questions. I may not be the best one to answer these questions, but I will either try or certainly get questions to Tanya and Joey to get answers back to anybody.
Anyone? Hold on, Vince.
That was really neat. Is this on?
Yeah.
Okay. I don't know if you can answer this, but I'm going to ask it anyway. All those spawning capable inshore, Nate, did you find any actively spawning females inshore also, or just spawning capable?
They have found spawning, actively spawning males and females. Anyone else?
Yes, hi, Paul McLaughlin again from the Lake Charles office for Louisiana Department of Wildlife and Fisheries. In that last couple slides in the back, we found that a very large mature female in the estuaries instead of finding her offshore. What was the overall histological state of her ovaries? Did she have a lot of fertility in whatever ova were available? Did she show any signs of maybe having spawned offshore and coming back inshore, like any signs of POFs at all?
So they have not actually finished the histological assessment of that individual. So I don't have that answer yet, but I'm sure that Joey, we can get it to you. Yeah.
We've got time. Anybody else?
Thank you. Mike Leffler, North Carolina Division of Marine Fisheries. Just a quick question on spawning success. you've seen active spawning occurring in the estuaries. Have you collected any live larval fish within the estuary that may have come from that spawning?
That is a good question for Joey. I'll have to run that back by them to see what they've collected for that determination. Thank you.
Hi, I'm Paul Casey with Texas Parks and Wildlife. You might have mentioned this, but what was the salinity in that habitat where you caught that mature female?
That was in the upper estuary, so it was probably less than 15, but I know the temperature was 10 degrees, and actually I can try and see if he had it in his notes. He gave me quite a bit of data on some of these fish. No, unfortunately, their notes just mentioned the temperature was 10 degrees at the time of capture, captured in February of 2021.
Thank you.
Going along with that winter, Patrick Graham. Going along with that winter spawning capable fish, has your group looked at maybe some otolith microchemistry to look at like differences in signature origin, to look at maybe higher salinity versus lower salinity waters?
I'm not aware that our folks have looked at any flounder with that technique.
Hi, Phil Stevens from Florida. Okay. This might be for Fred, but I was wondering what the juvenile habitats mainly being in the oligohaline zone, of like how the oligohaline zone is doing in these states. I know in Florida it's a target of a lot of our minimum flows and levels, and we're just kind of hang on to the oligohaline zone. So I'm wondering if we've seen any loss of that habitat or what the status is.
Yeah, I don't think that I'm one to speak on potential loss of habitat in that part of the estuary.
Goodness gracious. So just in North Carolina, there's been a big effort. For a long time, they've had protections for primary and secondary nursery areas, and there's been a recent designation for strategic habitat areas, and those specifically have gone up into these oligohaline reaches, and trying to understand the value of those habitats and whether or not those can be protected. Because in many of the coastal rivers, it's those oligohalines that are impacted a lot by watershed uses, like particularly industrial uses in that part of the watershed. And so I know that the coastal fisheries are starting to think more about the value of those habitats that are not as salty. But I don't know in terms of whether we have a sense overall as to the state of those, broadly.
Last one. I didn't know Derek up last night. Nancy Brown Peterson, University of Southern Mississippi. So you think that there's maybe some fish that aren't doing the migration. They may be spawning inshore. Your graph of the phases had very few regressing fish. So is there any indication that maybe they're sort of gearing up and then they're just regressing down? You talked about potentially skip spawning. I was wondering what your atresia looks like. I mean, again, I don't know if you can answer any of that or not.
Yeah, Joey may be able to answer that better on the histology side of things, but I think that there's also many fewer samples on that end of things. And one of the things that I haven't talked about yet, I'll talk about this afternoon, is our new stock enhancement program has a portion of funds dedicated to our inshore fisheries group so that we can answer some more of these questions, and so add some more funds to that pot to look at some of these things that we have a little bit of data for and say, here's a handful of hypotheses, and hopefully we can look at those more. But yeah, we see quite a bit of
evidence of skip spawning in our Southeast Reef Fisheries survey and fish that they work with. And so we've done some work with histology and NMR metabolomics to try and look at those signals and cues. And so maybe something that's transferable to southern flounder or an estuarine species, but it's nothing that we've gotten to yet.
Appreciate you pinch hitting there, Aaron. Next up, we have Dr. Sean Powers going to talk to us about pop dye in abundance, southern flounder in coastal Alabama.
I think I can. I'm a pacer, but all right, I'll let you figure out which one. All right. I guess I'll try this one first. Thank you. I'm here to talk about a stock assessment that we've conducted in Alabama coastal waters, and also give you an update since that stock assessment. And let me see if I can work everything. All right, so what I'm going to try to do is review the results of the 2017 State of Alabama assessment that was done in ASAP. I know we'll hear another presentation with ASAP. So 2017 is the terminal year. We actually did the assessment in 1819. ASAP is an age structure model that has projections capabilities. I'll talk a little bit about those details and why it's a good model and also why it's not perfect. Based on that stock assessment, the Marine Resource Division proposed some management changes. So we'll talk about those, the rationale for those, and then review some updated indices and landings to see if we see any signs that those have produced any results. And then just briefly talk about some exploratory analysis we've done with temperature and salinity deviations to explain the recruitment deviations that we've seen. So this is landings of flounder, which are Gulf and Southern. The stock assessment I'll talk to you about is specifically for Southern. But you can see a couple of things. Obviously, the declining trend we see in landings that many states have seen. The other thing is that the fishery is dominated by the recreational fishery. The commercial is becoming an ever smaller and smaller piece of that. Our commercial fishery has several different gear types, but largely it's a gill net fishery. There's some gigging, but it's relatively small in the commercial fishery. And again, this is Gulf and Southern. You can see here that Gulf is a fairly small percentage of it, although in some years it can be a decent percentage of the total harvest. Because of some of the new regulations, specifically the increase in size, we'll probably see this obviously more dominated by Southern in the future. But so, again, a couple of things to take away. Obviously, the strong declining trend that's been there for quite some time, or since 2010, 2011. As far as some of the pop dye and age structure of it, the fishery has historically, this is the commercial across all years, has been dominated largely by 1 and 2 year olds and very few older age classes. Recreational is similar. It's dominated by 1s and 2s. And again, this is before the new size limit from 12 to 14 inches has come into play. So we have this by year. Obviously, we need that for the stock assessment inputs, but I'm just showing you the overall picture. We also have the age structure for the fisheries independent indices that I'll show you in a little while. The goofy transitions are totally a product of my 12-year-old daughter who thought my talk was very boring and usually works on my computer, so there is no telling what kind of transitions or maybe pitches you'll see. But she tries to help me, which is good. So the age-structured model, like I said, is ASAP. That's available from the NIMFS toolbox. The version we used was updated in April 2018. ASAP is a good model for this. There's been a recent article in Fisheries Bull that compares it to stock synthesis and some more advanced models. The only trick with ASAP with flounder or southern flounder is it's not great on sexual dimorphism. It doesn't like different growth curves. I don't think that's a problem for this fishery because as long as you assume males aren't limiting and the fishery is mainly females, that's probably not much of a problem. But I'll be interested to hear from others who've used ASAP how they deal with different growth curves. We model it as two fleets, commercial and recreational. Again, we could have fine-tuned the commercial fleet because we have a lot more information on gig and gillnet and different modes. But really, given that the commercial fishery is relatively small component, we just modeled it as two fleets, the commercial and recreational. We do not have discards in the current model. As the size limit gets more and more prominent in the fishery, we'll probably have to start dealing with discarding. It's age structured. That's supplied by the Marine Resource Division that does all of the intercepts as well as all of the aging for it. The abundance indices included the Fisheries Independent Gillnet Survey, which is an excellent study, a survey that allows us to look at age structure, allows us to look at a few things. The selectivity of that gillnet survey is well known. And then the MRIP CPUE index is linked obviously only to the recreational fleet. It's as good as MRIP data are as far as number of targeted trips and harvested trips. And we'll talk about that in a second. So just kind of an overview. The stock is in poor shape. Overfishing is occurring in the stock. That's primarily due to the low recruitments that we've seen. The stock was not classified in 2000, that should be 17, as overfished. A little bit of that is because the terminal year in the stock assessment was more optimistic. And that's generally, a lot of times it's hard to, you should put limited faith in the terminal year of a stock assessment because a lot of that information is preliminary. But so right now, the stock condition is not overfished, although it's very close, but it is experiencing overfishing. And you can see here the spawning stock biomass. Again, this is Alabama only and southern flounder. So we see the spawning stock biomass increasing over time and then obviously rapidly dropping off. And then you can see it hit a low point in 2004, 2015. And then the model projects an optimistic terminal year, which I'll show you in a second did not happen. Most of that decline is dealt with as a result of the low observed recruitment. So the Fs historically have been relatively high. The scales are different on the commercial and the recreational. Obviously in 2014, if you have a very, very low stock and the number of directed trips is still high, then you're going to have a high fishing mortality. And then fishing mortality in both the commercial and the recreational has dropped off dramatically as a result of just low stock abundance. So in light of that, and I'm happy to talk about more and more details of the ASAP model, the important thing is we didn't get a very good spawner recruit relationship. We got some spawner recruit relationship. That's not surprising given that we're dealing with a relatively small geographic area. The spawning stock biomass is probably shared at least with Mississippi. But there was a fit to the spawner stock recruit relationship. It just wasn't very, very impressive. So the state, in light of these findings, as well as this just confirmed what the fishermen were telling them, changed a series of regulations. The first was the size limit increase from 12 to 14 inches for recreational and commercial. These went into effect in July 2019. Kevin Anson can give you any more background on these. The fishery closure was installed from November 1 to November 30th for both recreational and commercial. This from the feedback I got from the fishermen, particularly the commercial, this was the most unpopular thing they did. And hopefully Dylan Keene's study on acoustics and tracking and out-migration timing will reinforce why we chose that time period. Bag limit changes, recreational decrease from 10 to 5 flounder per person. Commercial, there was no bag limit previously, and now it's reduced to 40 fish per angler per day. So why did we choose 14 inches as the minimum? You can see here these are some management strategy evaluation tools that are available. We did a series of MSEs to inform what we wanted to do. And you can see the spawning stock, our targeted biomass is 30%. Target SPR is 30%. So we're assuming that this is a relatively productive stock normally. So at 30%, and the current F in the population, 14 inches gave us the ability to rebuild that stock to at least a 30% spawning stock biomass. 12 inches, the previous one, it would have been very, very difficult under any kind of fishing mortality regime that we were measuring to rebuild that stock. So that's essentially why we chose 14% was an examination, and the assumption that we could manage the stock at a 30% SPR. So how have we done with the updated indices? So this is the catch per unit for the recreational landings. And so this is harvest of recreational as estimated by MRIP, plus the targeted and harvested trips. So when you go through the system, obviously there's a primary and secondary targeted species the anglers list, and then you can include the harvested trips where they do. This is a little difficult for flounder because in our neck of the woods at least, sometimes flounder are targeted, but often they are not the targeted species on the trip. They're usually going after red drum or speckled trout. They will keep the flounder if they catch it. There are some cases where people target specific times of the year. So the number of trips, there's several ways to look at whether a trip is targeted. We did the simplest, which is targeted plus harvested trip. There's a McCall estimator. There's where you look at associated species. So the number of targeted trips is probably artificially low here, is the point I'm trying to make. But you can see clearly in the recreational catch per unit effort, it is decreasing. Now there is in 2021 an increase, a substantive increase in the catch per unit effort. But again, this is preliminary MRIP data. Oftentimes in a stock assessment, the terminal year is changed. The whole data series for MRIP has been changed because obviously they've increased the number of targeted trips in the recalibration. So, but it does reinforce what the anglers are seeing and what the model is seeing. And it shows us that conditions probably have not improved. If you look at the mean size, again, this is from MRIP data from Alabama. You see it, the size has increased over time. The last 2 years in 2019, 20, and 21, 3 years. It's nice to see that because that implies that the regulations are taking into effect. The Fisheries Independent Gillnet Survey, John Mariska can talk to you about the design here, but it's a large random stratified design with different zones. It collects several different species. It's not surprising it's zero inflated because the flounder aren't always a common catch. So we modeled it as a negative binomial with several environmental covariates. That's the other great thing about the data set is it takes lots of environmental covariates. The index is relatively constant, increasing. This is, again, gillnet, large panel for the most part. And then about 2011, 2012, the index crashes, and unfortunately we haven't seen it do anything but hover around the low mark. Some biological parameters. I think I have like 30 seconds. Yeah. Male to female ratio for the fisheries independent gillnet surveys are about 80% female, 11% male. But obviously you have to take that into account with the selectivity of the gear. Flounder are not fully selected for the gillnet. This is the large mesh panel on the gillnet to about 250 millimeters. If you look at the sex ratios over time, I haven't been able to update the commercial and recreational. We think those will change because of the new size limits. Fishery independent, though, is ranged from 26 to 1 to 6 to 1, and now 13 to 1. And again, keep in mind the size selectivity of the gear. We looked at recruitment deviations, and I know Troy is going to look a lot more at this at his talk, so I'll probably skip ahead, but essentially this is what's driving the model. We have nothing but negative recruitment anomalies since about 2012, 2013. And we didn't find a strong relationship with winter temperature or recent salinities during that November time period, which is what we were looking at, is whether outmigration was compromised and whether that could or potentially change, and that could explain some of the problems. So in summary, the stock status appears unchanged since 2017. The stock is still experiencing overfishing and is likely to be considered overfished now. Low recruitment continues. That's the take-home message. We didn't find an apparent relationship with late fall temperatures or salinity anomalies in recent years and the low recruitment. And then we'll have to see how the changes in the regulation have affected this population. Thank MRD, John Mariska, and Kevin Anson for their advice and obviously all the data their agency has. Mark Albans and Dylan Keene. Dylan will be speaking tomorrow about some acoustic telemetry work we've done in the past. Steve?
All right, we have time for a couple questions.
Yeah, this is Fred Scharf from North Carolina. So, yeah, Sean, that was a neat talk. I was wondering, what do you think has kept the commercial fishery from growing, and kept it sort of small over the years? You were saying there's a lot of gears, a lot of it's gill netting, and in North Carolina, the gill net fishery ended up at one point, we had catches that were approaching 4 million pounds in a year, right? And a lot of that was gill net catch. And so what do you suggest has kept it low in Alabama waters?
I'm not sure about that unless Kevin or John want to mention why the commercial fishery.
Kevin Anson, Alabama Department of Conservation. We've had a moratorium on gillnet licenses for some time, and actually, they have to renew each year, and if they don't buy that license, they lose the license. So that's the main reason that we haven't had an increase in landing, I believe.
Thanks, Kevin.
We got one more.
Hi, Kenneth Erickson with Tech Global. I noticed in the sex ratio data you were showing the quick recent survey, it looks like
not have a fisheries independent index in the state that targets smaller species. So it's really just speculation. I mean, it is a decent amount of catch in the early years. I guess I would be hesitant for anything just because of the relatively low catches in the recent years to interpret that sex ratio.
One more talk before the break at 10. And I'd like to introduce Josh Waters, who's going to talk about relative abundance of southern flounder in coastal Mississippi.
See how loud this is. Can everyone hear me? All right, I might get a little low throughout the talk. Just bum me up. No one wants to hear some flounder ASMR talk this early this morning. So today I'll be talking about monitoring relative abundance of southern flounder in coastal Mississippi with the use of our FIKE nets, representing Mississippi Department of Marine Resources as well. All right, to start out, we're talking about first implication of the issues we've had with southern flounder. Our advisory commission in June 2018 voted to decrease the daily bag limit from 15 to 10. This was a big stakeholder concern, along with the advisory commission. Adjacent states have done the same approach with regulation changes, applying new size and bag limits. Along these three states, like Texas, Alabama, and Florida, with Louisiana, have also implemented seasonal closures for no harvest of flounder with the recreational and commercial side. But with all these things in mind, downward population trends, we decided to implement FIKE-net as an appropriate fisheries independent survey method. Just start out with the harvest trends we've seen in Mississippi. This is a recreational and commercial side. Recreational database pulled from the MRIP query tool with the FES models. And for commercial, our biggest factor is gig. So did the CPUE for that. As we can see, it's a downward trend from 2010 to 2021. We do have that one weird 2019 in the recreational, but aside from that, you can almost see it's a downward trend. 2020 is our lowest of the past 10 years. So going on to our sampling gears, the FIKE-net. There we go. This is the FIKE-net itself. This is a brief overview of one of our sites on Deer Island. It was constructed of specially treated plastic mesh that extended 50 feet out from the shoreline. As you can see here, increments of PVC pipes, 10-foot by 2-inch pipes were used at every 5 feet, just to keep it stationary. And then on the side right here, we have two wings. It's kind of like a V-shaped formation. Essentially, it's supposed to just be as a funnel. So theoretically, fish hits the netting, goes down, and for the trap right here, we have two entry holes, one on each side. They either go into the trap or they will either funnel around, get stuck in this V shape, and eventually go in. The traps itself, or I like to call them dog kennels, because they kind of look like it. We're constructed using 1.5-inch square crab trap wire, and the traps themselves are 4.5 feet in length and 2 feet in height. For the funnels, we decided to go just 1.5 inches above the bottom of the trap, and was 16.5 inches in length. All right, so for locations, the start of this project in 2018, sites were discussed with GCRL, and we decided to do the Back Bay of Biloxi drainage system. So the three sites we decided on were north side of Deer Island, Davis Bayou, and Bellefontaine. This is Deer Island, Davis Bayou, and Bellefontaine. These sites were selected due to the habitat that we thought we would see flounder in, and natural sandy beach areas, and they're also for the ease of access for sampling. Sampling periods were from May to November on a biweekly basis, Typically, we would deploy on a Monday morning and then pick up on Wednesday morning. So that's a 48-hour soak. But in 2021, we got additional funding through the SURF program, and we decided to cover, decided to cover all three of our major drainage areas. GCRL took over the Bay St. Louis drainage, but along with our Back Bay of Biloxi, we took in the Pascagoula. Unfortunately, we could only get 2 sites due to the selectivity and difference of habitat in the area. The first site that we started was the northwest end of the Coast Guard Island, or PG1 as we like to call it, and then around the Pascagoula River Marsh area, which is PG2. So for field sampling purposes, we recorded water quality on the deployment of the trap and the pickup of the trap. For flounder, we retained any that were sampled, brought back to the lab. We measured total length, standard length, grabbed weight, removed otoliths for later aging, and determined the sex and gonadal development. In 2021, we also had a separate project for acoustically tagging the fish, and if the fish, we decided to kill 2 birds, 1 stone. If the fish was of the targeted length or greater, we would tag the fish out of the pike net and later just record total length from there. As you can see right here, this is me during the process of picking up. Might be wondering why straight arm out. We get a lot of stingrays and hardheads. Found that out one time. That was the only time I needed. But we've had a lot of, we record bycatch from everything, and it's crazy to see. Probably the coolest thing that we caught from bycatch standpoint was a 18.5-inch triple tail, which you wouldn't think you get a triple tail, especially on the bottom like that, but it's pretty interesting. But we've gotten everything from alligator gar, just a whole bunch of different species. All right. And so for the main point cross with this, this is gillnet data from 2012 to 2021 from Mississippi. This is our only traditional independent survey that we use for sampling flounder. As you can see, there was only 113 flounder captured in this time range with 1,008 sampling events. But in FikeNet, from the totality of the project from 2018, 2021, we've been able to capture 244 flounder in 53 individual sampling or across the station sampling events. And we've been able, but individually, it's only been 181 traps that we've retrieved from deployment to pickup. For a length and sex distribution standpoint, our smallest flounder that we've seen is 194 to 482 millimeters. You can see here in the, oh, my asterisk isn't there, but Pascagoula obviously was not sampled in 2018, 19, and 20, but in our first year with Pascagoula, we saw a lot smaller fish, and you can see in the mean total length right here, which was crazy because we had such an abundance of catch just within those 2 sites. And you can see right around here in the middle was our lowest over the scale of this project. And that's the size range right above 12 inches, which is illegal fish in Mississippi. So that was, I think it was around 305 millimeters, 304.8, I think, is around the 12-inch standard. So you can see the bigger fish in Pascagoula or in Biloxi compared to Pascagoula, but we only have 1 year of the Pascagoula sampling to back this up. And for the sex, we've only seen 2 male. They're both immature, and that was in the past year in Pascagoula in 2021. You might be like, well, you said you caught 244. That's only 182. Well, the ones that we tagged, there's around 40, 41. We're still waiting back for the sex on those fish. And crabs love flounder gonads. It's a big, big thing. So, I mean, one time I had the trap in there and I had 121 blue crab total, with 4 flounder just destroyed. And there's probably another 70 on the net itself. So that's another thing that we run into with that. And it's probably around 22 of them that were like that throughout the years. So going into monthly CPUE, we factored this on the calculated by subtracting the deployment from pickup time. You know, we're not always guaranteed a straight 48-hour set, so we divide that by the, once we get the hour total, divide that by the number of flounder, and then we would get the monthly averages with the terminal year, and we would also, and next slide, we got the annual year CPUE for the entire data set. But you can see here in 2018 and the later years, besides 2019, a decline in catch in the end of spring and beginning of fall. 2019, we had many factors that I'll go into later, such as the large influx of fresh water that we saw in coastal Mississippi. But overall, a rise in total catch for summer months. You can see on most years, 2020 was a weird year. I think we can all agree on that. Of course, it would reflect here, but in Pascagoula, we have had our most success with PG1 side in its first year of sampling. I think by station, here's the annual CPUE, but by station, we have had 80 in Bellefontaine, 43 in Pascagoula, Pascagoula 1. Davis Bayou's only had 41 fish. Deer Island 66, and Pascagoula Site 2 only 14. But the weird thing too with, or the crazy thing too with Pascagoula Site 2 this year is anytime we saw fish or flounder in the trap, it was always 2. They're all female, but they were always 2 fish, and they were mimic the same length and weight. So that was something interesting we're going to further look into. And aside from environmental comparisons, we ran some linear regression models. We saw a slight positive relation with salinity and temperature, but it wasn't, the R-squared value was extremely low, but you could see in trends there was some sort of a positive relation. But I grabbed 2019 for an example because of the large influx of fresh water that we had. So you see in May, I think it was around 3 parts per thousand. And then finally, once we had some catch, but they were not in great shape. And then once the salinity doubled up and our average was around that 18 we've seen in past years and previous years, the catch rose again. Salinity stabilizes, kind of evens out, catch declines, stays the same, but we see another change in salinity, major change like that, and catch rises. So maybe it's just they move more with salinity changes. We're not really sure. We're taking all this into consideration because we're just doing essentially snapshots of the water parameters, and we really need, like, for further usage, we're going to be using data loggers that have real-time 24/7 tracking, so we can use those instead, because a deployment, getting water meters 48 hours before and then after the pickup's not really a good set or database to use. So summary, 244 flounder were caught. Pike nets have been shown to be more successful than other sampling efforts like the gill net we have in Mississippi. The impacts, environmental factors are under review, and results of this project could aid in future management recommendations. Future direction will begin sampling again in May 2022. Continue to assess all the environmental factors. We're hoping to establish a third site in Pascagoula drainage, but like I mentioned before, it's extremely hard with the area that we're given. And lastly, potentially add the data loggers for the continuous monitoring of the temperature and salinity and other factors. Improvements, as always, we can enhance sampling design to increase catch rate. And the problem we have during the summer months is potential fish kills. So 24-hour checks could be used, and we could improve on the funnel design on the bottom of the traps to collect bigger fish. And with that, I'd like to thank all my colleagues and staff at MDMR. Couldn't do any of this without them. GCRL staff and the different programs that help fund, like Tidelands, Sportfish, and the Surf program. And with that, I'll take any questions.
We do have time before the break. Any questions?
This is Steve Midway, LSU. You made it clear that the fyke nets were more productive or had better capture rates than the gill nets. But when you mentioned the site selection for the fyke nets, it sounded like they were sort of expert opinion based on where you would expect to catch flounder. And I'm curious if the site ID or the site location may be affecting how that you're just getting more fish because you identified spots where there may be more fish than where the gill nets are fished.
Yeah, we will take that into consideration. Like the main purpose of the project was to just show an abundance trend, and we needed initially to determine different areas where flounder are, and the sandy habitat has been the most productive. We have done experimental fyke nets in for the flounder tagging in the past year, just on random sites, but we have also seen as good of catch in the sandy compared to marsh. So, but yes, we're going to look into that.
Hey, Josh, Troy Farmer, Clemson. Was just curious about what your, did you sample all months with the fyke nets? Can you remind me, or was that just restricted to a certain season?
They were sampled May through November.
May through November, okay.
Sorry.
Gotcha. I was just curious if you had any observations, following up on Aaron's talk about developing females and your histology in relation to what that looked like. Have you guys been able to dig into that data yet?
No, sir, we have not. But we are limited with the 50-foot that we have for the fyke net. November, once the tide goes out, the trap is not always submerged, and we found that out after the first year. So that's one of our problems with continuing throughout a yearly or annual sampling.
Gotcha. Thanks.
Yeah, this is Fred Scharf in North Carolina. I was wondering, had you guys looked at all at trap saturation based on soak time, and whether or not you were, maybe try different soak times to look and see how your CPUE is impacted? I wonder if you get to a certain point where you just can't, the trap isn't going to hold any more fish. And I was related to that. I was also wondering, do any of the sites have sufficient visibility where you could have cameras on the traps where you could look at sort of movement of fish in and out of the traps? I'm guessing no.
We've wanted to, but no, we don't have that in coastal Mississippi. It's always turbid. But as far as saturation, we have initially when we were first starting, we did the 24-hour checks, but it is a lot on staff to be doing every other week. 24-hour checks, going on the boat, checking, coming back, and doing all the other things that we have to do. But I can say during the first 24 hours is what I've seen to be have more fish, because we do periodically the 24-hour checks during the summer months because of low DO or any fish kill event like in 2019 with all the fresh water and the harmful algal blooms we had. So we were doing more frequent checks, but yeah, the 24-hour mark was really a big thing.
Anyone else? Works now. Okay. Thank you, Josh. We're going to take a break. We'll come back at 10:20 for anybody online. You please want to switch to session, or no, it's still the same session. We'll just be on a 15-minute break. If you did not pick up your registration information, we're going to be back out here in the hall. You can get all your beautiful goodies, your name badges and programs. Thank you.
Oh, yes, sir. Clint Eads. I work out of the Grand Isle Lab.
Yes, sir.
And man, we just started doing some very similar work with the lake.
I think I talked to y'all one time, and I know Trevor's been in contact with y'all as well.
So I had one question. What do y'all like you said you had 4 or 5.
Yeah, I came from like 2 blocks away. Our lab is really close.
Okay. So it's usually that Monday morning from Wednesday morning. We run it depending on weather, so it's not always Monday morning. It could be Tuesday, it could be Wednesday. But aside from that, other environmental factors such as tide, the wind.
Well, we're doing that right now. So one interesting thing that really little. Yeah.
I got my we're starting to look more tide. I forgot to mention that. So, we're looking, I'm comparing all past from 2018 to 2021, the title differences, but it's just so much that we've been trying to go through.
Well, the good thing about that is that's all you don't have to that. But now we record. What we do, all right, so me and Erik are on the product. So, that's Monday through pickup Thursday. We're checking every 24 hours. But, as well, so we under stress, great. So we do the 24 hours, or 24 hour check, weather permitting. 24 hours, 48, whatever. So I guess so. We're doing that. We're going to record that. And one thing that's weather. Yeah. So this is causing movement, especially in the later season.
Yeah, like 35.
The black net is.
Thank you.
So
Don't give that crab design to the crab fishermen.
Yeah.
And that is the top, if I can remember. I was shocked that the commercials were so.
Joe, this microphone isn't turning off.
On rockers. On
Erik Lang. Can you go up to the podium? Joe's going to walk through what we're going to do next. Nicolette and Henry. Nicolette and Henry.
Henry Hershey, come to the podium, please. Henry Hershey, come to the podium.
Hello, we're going to go ahead and get started again. We're giving our speaker 1 second on an update. We are already a couple minutes behind, but we're going to shift everything by a couple minutes, so if we can go ahead and get started. You can use that or that mic. He's going to bring that up, the one in front of you, and they can wander with it.
Okay, perfect. All right, welcome back from the break. We'll get right back to business here. Dr. Troy Farmer from Clemson is going to be telling us about environmental correlates to flounder recruitment in coastal waters of Alabama. I believe this comes off.
All right, thanks, Steve. As Steve mentioned, I'm going to be talking about some environmental correlates of southern flounder recruitment in Alabama coastal waters today. Before I get started, I just want to acknowledge our funding agency, Alabama MRD, through Sportfish Restoration, and also want to say thanks to Kevin Anson and John Maresca for providing the great long-term data that we relied on for this project. Also want to acknowledge a master's student. Everything I'm going to be presenting today was Megan Angelina's work. She was a master's student at Clemson. This was the first chapter of her thesis. Megan had a pretty ambitious thesis project. She initially was hoping to look at sex ratios across this really nice temperature and salinity gradient in Mobile Bay. But because of the really low recruitment that Sean highlighted in his talk that we've seen in Alabama coastal waters, we just weren't able to get enough age 0 southern flounder to actually accomplish that. So Megan, in kind of a shift, conducted the work I'm going to show you today, which is her first chapter of her thesis that looked at historical recruitment in Alabama. Megan's now over in the Brunswick office with Georgia MRD. There we go. So as we've seen from several talks now, recruitment can be highly variable, but we've seen that declines in recruitment are evident from recent stock assessment, both in the South Atlantic and in Sean Power's stock assessment for Alabama coastal waters. You'll see in the top plot here, Sean already showed some of these data in his talk, but you can see in recent years, these are the residuals from the stock-recruit relationship. You can see in recent years, all of those residuals are negative, indicating that recruitment was lower than we expected based on the stock-recruit relationship. Now, take that with a grain of salt, right? I think the stock-recruit relationship was kind of an okay fit, but some evidence that recruitment is low and potentially declining in Alabama coastal waters. So for this project, Megan was really interested in looking at controlling factors, those environmental factors that generate variability in recruitment. We know for a lot of flatfish species that year class strength is likely determined prior to the juvenile stage, and Fred showed some nice relationships between larval abundance and juvenile abundance, leading us to believe that factors that operate early in life during the larval stage have strong effects on year class strength. You've already seen some of these plots in Fred's talk. This is from Chris Taylor's work in North Carolina, where he identified several environmental variables during the early life stage, likely during the larval stage in North Carolina. February to March, wind speeds and direction were important in explaining recruitment variability, and also river discharge had a negative effect on recruitment, likely, potentially, maybe Taylor hypothesized inhibiting larval movement into the estuary in years of really high inflow. So the objectives for this work is that we wanted to develop an annual index of southern flounder juvenile abundance in Alabama waters to look at temporal trends to see if, in fact, we do see a declining trend in those juvenile catches. And then the next step, once that index was developed, was to examine relationships between juvenile abundance and some potential controlling environmental factors. The three we looked at were winter duration, so the length of winter, which might indicate the length of spawning for these flounder as they move offshore. Also winter river discharge, which has important effects on larval ingress into the estuary and estuarine conditions. And finally, winter winds, which of course can be important for larval transport. So our study area was Mobile Bay. It's the 4th largest river system by volume in the US. There's a really strong temperature and salinity gradient that exists in Mobile Bay. And the FAMP data that was collected has been collected kind of across this salinity gradient. We also have some sites over in the Mississippi Sound, which I'll show you here in a minute. So the long-term data on southern flounder juvenile abundance came from Alabama MRD's Fishery Assessment and Monitoring Program, or FAMP. This survey runs from 1981 to present. They have 12 sites that are consistently sampled across Mobile Bay. And it's conducted by otter trawl, 10-minute otter trawls, and all species that are caught are identified and measured for total length. So here are the sites that you can see in Mobile Bay. And then we have a few sites over here in Mississippi Sound as well that contributed to the index. So in developing the index, Megan had to do a couple of things before she could actually develop the index. The first thing was she looked at annual average catch by month. And so here you can see southern flounder mean catch per unit effort by month. And you can see there's a clear peak in southern flounder catch in the FAMP survey from March to May. The next thing Megan had to do, this is all southern flounder together. The survey primarily catches smaller than southern flounder, but we do see larger individuals in the catch as well. So the next step that Megan conducted was to actually generate a total length cutoff to separate our age 0 fish from our age 1. I won't go into all the details about how Megan did this today just due to time, but this line right here, basically from another subset of fish from gillnet catches and boat electrofishing surveys, some of which were done by Auburn University in previous years, developed this cutoff between age 0 and age 1. So anything below this dotted line is likely an age 0 fish. Anything above it is an age 1. And then the vertical bars here represent our March to May window. So you can see the survey does a really nice job. Every dot is a flounder that was collected during the entire duration of the 38-year survey. And you can see there's a lot of age 0 southern flounder here between March and May. So the survey does a nice job of capturing those fish that we're looking for. Megan also corrected for environmental effects on catchability. I won't spend a lot of time here except to say that she didn't find a strong effect of temperature or dissolved oxygen. These are measured at the time of trawl collection. But she did see that there was an effect of salinity. Again, indicating what Fred was saying in his talk, possible preference of low salinity waters for southern flounder. You can see the black dots here represent a trawl that caught a southern flounder, and the open white dots are trawls that did not catch southern flounder. So you can see most of our southern flounder catches are below 15 PSU. All right, so now getting into the environmental variables that Megan looked at. We were really interested in offshore winds. So Megan collected wind data from the National Buoy Data Center right off Dauphin Island. And she classified wind into kind of 4 prevailing directions, northeast, south, and west, and summed those wind speeds for each direction from December to February during the offshore spawning period where you'd see fish spawning, larvae being produced, and then potentially transported inshore. Megan also summarized river discharge by summing the most downstream gauges on the Alabama and Tombigbee rivers. These are the 2 primary rivers that feed into Mobile Bay and really drive the river discharge dynamics of the system. She came up with monthly averages and then summed those across December and February for each winter to have kind of a cumulative index of river discharge during the winter. That really drives the salinity dynamics in Mobile Bay and can also at that time cause these kind of large offshore plumes that extend several miles out from the mouth of Mobile Bay into the Gulf of Mexico. Megan also wanted to develop an index of winter duration. We've seen a lot of recent warm winters in the Gulf region, and we were interested in how these warm winters might be affecting recruitment. One of the limiting factors was that we didn't have a lot of water temperature data from our region. We had a nice buoy off Orange Beach that had consistent data from 2012 to 2016, but we didn't have long-term water winter temperature data. So Megan developed a nice relationship between air winter duration, as you can see here on the x-axis, and water winter duration, and then just use these air winter duration index to kind of predict waters. We had an R-squared of 0.94, indicating there's a really strong relationship, as you'd expect, between air and water temperature. All right, so once we have that juvenile abundance index and our environmental variables, Megan used generalized additive models to determine the relationship between these environmental variables and juvenile recruitment. I won't get into all the details here, except to say that we did use a negative binomial distribution. As Sean mentioned in his talks, there's a lot of zeros here. I think something like 7% of all trawls actually caught a southern flounder, typical of southern flounder survey data. And then we used a backwards stepwise selection method to kind of determine the best model for each of our suite of models. All right, so Megan had two key analyses. The first analysis was a long-term analysis that covered 38 years. That included both winter river duration and, winter river discharge and winter duration, because we had both those variables for the entire survey period. She also included a shorter term analysis that was only 16 years, which was the duration of time that we had wind data. And she included winter duration and river discharge for that shorter 16-year analysis as well. All right, so now getting into some results. You can see on the left that we have a plot of all our 12 sites in Mobile Bay and Mississippi Sound with the size of the dot indicated with the average CPU at that site. See most of our catches, not surprisingly, were kind of in near-shore, shallow estuarine habitats. And then on the right, you can see the time series of our juvenile abundance across year. And what's most striking is that in the early time series, recruitment could be really high or low. It's highly variable. But really after about 2007 here, in the recent time period, we see consistently low recruitment. Again, indicating what Sean saw in his stock assessment, that we've just had low recruitment in Alabama waters and very low catches of these age 0 southern flounder in recent years. Now getting into some of the results from the GAMS. For our long-term analysis, our 38-year analysis, the full model that we applied was just two variables, river discharge and winter duration. And the best model in backward selection was actually that full model with both river discharge and winter duration selected. It explained about 65% of the variability in our juvenile abundance. And you can see on the left that river discharge had a pretty strong positive effect. So these variables are centered and scaled. But on the left here, this is low river discharge on the left, high on the right. And you can see there's a strong positive relationship with our juvenile abundance, where we saw the highest juvenile abundances in years with high river discharge. It's opposite from what Taylor observed in North Carolina. We can talk about why that might be. We have some hypotheses. For winter duration, we saw that short winters, which are over here on the left, typically had lower recruitment, although there was a lot of uncertainty of the effect of short winter durations on juvenile abundance. We saw our highest recruitment at kind of intermediate winter durations. And then at very long winter durations, we saw that recruitment declined as well, possibly indicating that there is some positive benefit to a longer winter, but that at very long winters, we see recruitment drop off as well, suggesting maybe there's some factors that it can be too cold for too long for southern flounder. And then we did some kind of leave one out analysis, looking at trying to tease out which of these is most important by basically taking winter duration out and looking at the change in deviance explained and change in AIC. It suggested that winter duration was explaining more variability than river discharge due to that higher change in deviance explained. All right, now for the short-term analysis, the 16-year analysis, you can see our full model had 3 different wind components, west, east, and south. We had to leave out our north winds because they were highly correlated with south winds, as you might expect. And then we also had river discharge and winter duration. And here our best model was just 2 wind components, east winds and west winds, which surprisingly weren't correlated with each other. And the deviance explained was pretty high. We had about 82, 83% of the variation in juvenile abundance explained, and there's a strong positive effect, as you can see here, on with west winds on juvenile abundance, with years with low, weak westerly winds leading to very low juvenile abundance, and years with strong westerly winds leading to some really high juvenile abundances. We saw kind of the same pattern with easterly winds, except we saw kind of a strange pattern at the low end with easterly winds, where we had a couple years that had very low east wind speeds. Those also had okay, decent recruitment. But overall, I think the trend here is that kind of a longshore winds in either the easterly or westerly directions lead to high juvenile abundance. So really importance of those kind of parallel winds along the shore during winter for southern flounder recruitment. We looked at the importance of each of these variables. We saw that west winds explain more variance than east winds. So west winds are probably what's really driving this best model. But east winds are also important. All right, to kind of summarize all of this and put it in one plot, Megan made this nice kind of tile plot of partial residuals where plots in green or light yellow indicate positive effects and red indicate negative effects. And so if we look at our, and I apologize, the green and yellow doesn't really show up great in this version of the talk. Everything looks really yellow. But if we look at our 6 best year classes in the time series, circled here, and then we circle those years in these partial residuals, and again, we have all 4 of our winter variables: winter duration, river discharge, and then west and east winds. For all 38 years of the data series, we only had winds for recently, hence we only have some observations in the tile plots for recently for those. But if we look at our years of strong recruitment, you can see that those years typically had, not surprisingly, good conditions for kind of all variables, indicating you had a favorable year for recruitment where you had a relatively long winter duration, high river discharge, and favorable winds. In recent years, when we've had poor recruitment, really since 2010, we see a lot of red showing up in this tile plot, indicating that short winter durations, lower river discharge, and weak west winds tend to correlate with the poor recruitment environment we've seen recently for southern flounder. So potentially suggesting the environment may be changing in a way that's less favorable for flounder recruitment in recent years. So again, these are just correlations, but thinking about potential mechanisms behind the correlations, we know that there's a strong positive relationship with juvenile southern flounder abundance and west winds. That could have a couple of different effects. We know that spawning, well, really interested to see what some of the movement and migration talks later show about where spawning might be happening. I don't think, when Megan was conducting her work, we had a great idea of what that was. She had an old report from 1982 from some scuba surveys saying that maybe 20 to 60 meters had some fish offshore spawning. I think there's a lot of uncertainty there. Fish are spawning west of Mobile Bay. Of course, there's a large opening in the Mississippi Sound where west winds could move larvae into the system in that direction. We also know that offshore parallel winds are really important, causing upwelling along the Gulf of Mexico, particularly westerly winds. So that upwelling has been cited in other studies, leading to high transport of eggs and larvae into estuarine regions. That could also be a potential mechanism. And it can also, of course, increase nutrients and phytoplankton and make just a better survival that's more productive for larval survival. And also a longshore transport might also be important in allowing larvae to find those estuarine entrances. For winter river discharge, if you remember, Chris Taylor found a negative effect in North Carolina of winter river discharge on southern flounder abundance. We found a positive relationship, and we think that's probably due to the physical differences of Mobile Bay compared to some of the North Carolina estuaries. There's been some work in Mobile Bay by folks at Dauphin Island Sea Lab that show that when there's high river discharge in this stratified estuary, we can also get high ocean influx into the estuary in the bottom layers. And that's what this rather complicated figure shows here. We have river discharge at 3 different levels: low, medium, and high. And what you can see is that when there's high net outflux, that new ocean influx also increases. So southern flounder larvae that are utilizing selective tidal stream transport to move into estuaries could potentially, at least hypothesized, use that increased bottom flow into the estuary to actually ingress into the estuary. Also, potentially more important, high river discharge during the winter likely increases oligohaline habitats in the estuary that might be optimal for southern flounder settlement. So these high river discharge may be contributing to just creating a better environment for southern flounder settlement and survival in the estuary as well. And then finally, we saw that intermediate winter durations had positive effects on southern flounder abundance. For several species, it's been hypothesized that longer period just increases the chance that some larvae will encounter conditions that lead to high survival. But we saw that there was some limit to this positive effect. When we had the longest winters, we saw poor southern flounder recruitment. That, of course, could be due to low larval survival or low foraging during really long, cold winters that might lead to low food availability. We've also seen for some other southern flounder species, and I'd be really interested to know what some aquaculture folks are talking later today think about this, but there's been some evidence from olive flounder and some other species that winter temperatures might reduce egg size. Warm winter temperatures might reduce egg size or quality. Potentially some of these warmer winters might be reducing egg size or quality. And not related to this study, but we know that shorter winters also can increase the potential for sex reversal, leading to warmer conditions in the spring, that juveniles in the estuary could encounter those warm conditions leading to the potential for sex reversal. I know we've got some talks on sex reversal coming up later today. That's not really a mechanism that would drive down our juvenile abundance index because that was collected kind of during the window for sex reversal, so it wouldn't necessarily affect the juvenile abundance we saw. But I think it's something important to note that that could be another negative effect of short winters that's not even showing up in this historical analysis. And I'll just note that recently, this is our time series of winter duration by year. And what you can see is that historically, we had somewhere between an average of 65 and 70 days below 18 degrees C in Alabama. But what you can see recently, the past 4 years were all extremely short and warm. So we're seeing this increased incidence of very short, warm winters on the Gulf Coast, again indicating potentially negative environment for southern flounder recruitment. So there's some clear climate signals. We expect that while these relationships were documented from Mobile Bay, we might see definitely some estuary-specific differences, and we've already seen that with the Taylor work that was done in North Carolina. But it does set up kind of a challenging environment for southern flounder. What we know or what we expect, we'll see from climate change is that we may see increased drought duration and increased heat waves and decreased cold snaps. There's been a recent publication that predicted that 90% of winters will be warmer at the end of the 21st century than previously recorded. So it's going to be, it looks like potentially the environment may be changing in a way that's detrimental to southern flounder recruitment in recent years. The expectations for climate change in terms of what we would expect with river discharge and winter duration may lead us to expect more of these conditions that we've seen in recent years. With that, I want to thank everybody that contributed to this work, our funding agency, and there was a large field component too that Jared Crisp will be talking about tomorrow with some of his work with otolith chemistry and isotopes to look at growth with residency in different portions of the estuary. And with that, just say thanks to everybody that contributed and take questions if we have time.
We do have a couple minutes. Questions?
Hi, Laura Lee from North Carolina. I'm just curious, you said there was like 93% zeros in the sampling events. I was just curious if you considered zero inflated model in addition to the GAM?
We did. So Megan did some kind of model selection to look at which one was best. And the zero inflated, the negative binomial was the best fit that we found. But we did look at that.
All right, thanks.
John Godwin, North Carolina State. I mean, to mention the warmer water and reduced egg quality, I mean, that's really interesting. And is it known as beyond small size? Did that translate into differences in hatchability or anything? Is that known? Or?
Yeah, from what I've seen in the literature, I don't think it's been documented, but I'd be really curious with some of the folks that have worked more with aquaculture for the species to know what they think. Smaller size doesn't necessarily always mean poorer quality, so that's a great point. Yep.
One more? Got to factor in the transit time.
Hey, Sean Powers, South Alabama. Troy, can you show your map on your catches? I was interested. You said that you had higher abundance and generally lower salinity.
That's right.
Was that? But that spot where you had the most was on the eastern shore. Okay, that's why I wanted to see, because one of the things I'm interested in is whether the delta and all that SAV vegetation up there is something we just haven't measured sufficiently either. But is that point clear? That big spot on the eastern? Oh, it's Weeks Bay.
On the eastern, right here. Yep, Weeks Bay, just below point.
Okay.
4. Yep.
So that's what's largely driving the low salinity, that and Dog River, I guess?
That and Dog, yep. Those are always two good sites and close proximity to fresh water coming in as well. But that's a great point about the delta. That's certainly the primary source of fresh water in the system, and
Well, it's all that SAV habitat up there too. Yeah.
It is, and Jared's going to be talking. We did some fishery independent collections up there with electrofishing and trawls. Jared will talk about that more tomorrow. But it's difficult to compare catch rates because we use different gears in different parts of the estuary due to salinity. So, but it's a great question. All right. Thanks.
Thank you, Troy. Should have scheduled a talk on the negative binomial distribution. Next up, Erik Lang, LDWF, is going to talk about a fisheries independent survey that includes life history metrics. Thank you. Thanks. How's everybody doing? At Louisiana Department of Wildlife and Fisheries, we decided to look at a different survey method. I think throughout the department, we've looked at a couple different survey methods, including electrofishing for southern flounder, because we have some catches in our standardized surveys that we've done for years now that aren't exactly optimal. So we're going to explore some of that, and then we'll look at some of the life history metrics that we've completed along with that survey from the catch of that survey. So if we look at, let me wake this sucker up. There we go. All right, so if we look at our annual catch since 2010 on some of our more highly known standardized surveys, we've seen a marked decrease in southern flounder, but we've ended up with numbers annually. So this is numbers per year of respective species. You can see that it's generates good numbers of spotted sea trout in the gillnet, good numbers of red drum in the trammel, but we depend upon trammel to inform the number of adult southern flounder, and lately we haven't really been getting that many. And the troll survey offers a good amount of juvenile small flounder, but we need those adult metrics. So this is just a simplified look at our effort versus our catch. And you can see that our effort stays consistent outside of an expanded sampling in the early 2010s. But you see that abundance is dropping off in both troll and trammel. But we want to get a better grip of that. So the new fisheries independent survey, when we were looking at some of this, it's very wordy, but I'll try and summarize. Basically, what we wanted to look at was, okay, when are the flounder most concentrated? When can we get the highest number of flounder? And how can we do that in a randomly stratified sampling design? And also, what kind of gear would we use? Well, we look to the commercial fishery for gear. A lot of commercial guys, not only on the Gulf Coast, but more on the East Coast, honestly, use pound nets to fish for flounder. Pound nets are a little bit problematic because, one, they mostly are stationary, and then two, you have to go through all kinds of Coast Guard rigmarole to get them set and stay there and pick them up over and over again. And fike nets are mobile, basically do the same thing, just on a smaller scale. So we wanted to go with the fike net survey. So here's our modified fike net as defined by the American Fisheries Society sampling manual. So we've got the rectangular, there we go, rectangular front with the lead net going in. The box is restricted as our first throat, and then you'll have the throat back in the hoop design behind it. You can see we kind of modified this net, a couple different net manufacturers with a couple of different net dips, but it works. All right, so for the experimental design, basically we wanted to make sure that we are sampling marsh sites in the coastal areas as well as sites adjacent to the pass or channels. So we have basically assigned 8 randomized stations on the backside of Barrier Islands and Barataria Bay, as well as 7 pre-selected. So basically when I say 7 pre-selected stations, it's just stations on either side of the Barrier Islands where the passes run through. And so we've got 7 of those because one of them, Elmer's Island, really isn't an island. It's more like a spit. So from those 7, we randomly assigned 4 pass stations. This was constrained down from us sampling across Barataria Bay. If you know anything about Barataria Bay, we have a lot of islands due to coastal erosion and a lot of different paths for flounder to go through. But with
some of that erosion just comes not a lot of navigable waterways and a lot of marsh flats that our boats really couldn't get through. So it became very cumbersome to try and get to the eastern side of Barataria Bay. So we really just tried to stay to the west so that we could be more efficient in our sampling design. And so what we did was we set out these 12 sampling sites, the marsh plus the pass sites, every single month, and soaked the nets for 24, 48, 72 hours. We're checking the nets every single 24-hour period. It's just that we attempted in that week to sample for a full 72 hours. So basically, this is our randomizing map. So I took a line tool and we outlined every non-anthropogenically impacted area. So some of these, this island looks, West Grand Terre looks very natural in this area, but there's a lot of restoration work done. So we wanted to try and avoid that area as well. So the green is our possible marsh sites. So that's basically the shapefile we use to identify the randomized sites for marsh. And then the, if you can see them, the little purple dots on each sides of these islands, and then Elmer's Island, we've got one little purple dot down there. Those are our 7 channel or pass sites where we would randomly select 4 from those 7. All right, so we have some abiotic data. So I'm just going to preface that this is our first real year. We had a year of 2020-21 where we sampled, and it was very experimental in us determining exactly how we would complete this survey. So we really don't have reliable data from that time, especially since the nets we were fishing at that time did not catch at the rate we wanted them to. But we used a lot of that experience to establish what we're doing now. So it was still a very useful sampling year. But we just really were finished all our data entry, ovary processing, otolith processing for at least up to this time period, like a few weeks ago. So it's very recent. So we just kind of cobbled this together very recently. So everything I'm presenting to you is preliminary. And on top of that, the abiotic data, we have it. I'm letting you know we have it, but it's not figured into any kind of abundance. All right, so for just November, I'm going to go into the life history metrics now. In just November and December, here's some of our age size distribution. We do have an outlier here as a 2-year-old fish in a very small area, and then an outlier here of a 1-year-old fish in some larger fish length bins. But for the most part, the takeaway is that, you know, takeaway is that we have only age 1 and age 2 fish. Wish that we had more, but them's the breaks. And I only chose November and December. You like that, Steve? I only chose November and December because October, you know, just to get more sympathy from all of you, Hurricane Ida hit us, and so we weren't really able to sample as much as we wanted to in October. We got like the last week of October, but for life history metrics, we're really constrained to November, December. By the time January rolled around, our ovaries were totally regressed. We had basically no spawning season to assess. So if we're looking at the binomial logistic regressions of presence of cortical alveolar or progressed, or vitellogenesis or progressed, so basically early developing or late or just developing, we get, of course, 2 different size metrics at L50. And then the ages, you know, we'd really need some of those YOIs to get the model to configure the percentage, the probabilities of maturity down. So basically, you know, Nancy coins this all the time as physiological maturity and then functional maturity for compensate for that gonadotrope-independent process of cortical alveolar. But for stock assessment purposes, we more use the functional maturity method. But so age, because we're so truncated in our age structure, our maturity probabilities at age really aren't going to yield much, and age 0 is not 50% mature. We all know that. And then, you know, judging from Dr. Scharf and some of you guys on the East Coast, you know, our maturity probabilities are at 50% or much smaller lengths, as you had mentioned, Dr. Scharf. So we also got an email from Nancy Brown Peterson, who was very generous in offering us some data to include, to add on. There's some issues, obviously, with the differences. One is that they're from two different states and two different regions separated by the Mississippi River. Two is that they were collected differently, and then three is that the GCRL data is from 2014, whereas ours is from 2021. But if we added them together, it does give us a good boost in our sample size. So wanted to see what that would do. So one, they had some ages, but a good bit of them were unknown as far as ages go. They were able to add some 3-year-olds to our sample. So again, I only took their data from November and December as well. They've got a full suite of data that's available in a publication by Nancy and Robert Leaf and Morgan Gorey. That's a really good synoptic view of flounder in Mississippi. So add a little bit of that, and then you can see a bump up in our L50 estimations. I just wanted to say too, obviously the age at maturity is not working out again, but the ROC I like for these binomial logistic regressions, I like to use area under receiver operating curve as an estimation of best fit. So the length, the maturity at length, both physiological and functional, you're getting about a 70% precision fit between the model accurately predicting a true case of maturity, and then that was for the original LDWF data, and then adding in the GCRL data gives us about a 4%. A 4% bump in best fit for this one, and then about a 1 or 2% bump in best fit for this one. So it helps it out a little bit for the fit metric, but not too much. We're just going to need more samples over time, and we will do that. So just to look at a little bit more about functional versus physiological. You really do have some overlap. It's not like the physiological is that statistically different, but observationally, the vitellogenesis does consistently produce a larger size at 50% maturity. All right, so getting into the catch. So before life history data, that was just November, December. Now we're looking at data from all the way from the first week of October through February. So this is just a quick calculation. So I just real quick looked at the TramelNet survey for just 2021. They had a 4% positive catch rate. Now, I realized that with our TramelNet survey, we're sampling all across Barataria Bay, whereas this is just sampling the barrier islands, regardless of the fact that it's a randomized design. But 4% is extremely low compared to the 43% positive catch rate for 2021-22 data that we were able to get with the FICENet. CV of 10 on that 43% positive catch rate. This is really just discrete. I'm not running a GLM or GAM or anything like that. But I did get a log normal mean of flounder per positive net day. So we just use net day as the effort measurement since we're fishing for 24-hour periods. And then, so the CV is kind of inflated, but that's really because we would have a catch of 1 flounder, 2 flounder, 1 ton, and then 24, and then 1 flounder, 2 flounder, and then 11. You know, so that resulted in the high CV for those positive catches. And then multiply the two together, and you get that IOA. I don't have multiple years of indices of abundance, so I didn't have a correlation coefficient to be able to determine the variance of the indices of abundance and therefore get any kind of CVs for it, but we will get that in the future. All right, so you can see our catch at location. I apologize for the splotchiness of the satellite image. I really wanted to get the most up-to-date satellite imagery as possible, so I got the LiDAR data after Hurricane Ida. Otherwise, some of these catches would look like they're in the middle of Barataria Bay when they're not. But you can see that really these pass/channel locations had a large amount of the catch. But marsh still did contribute some. All right, and then some interesting additional data. Back in 2011 through 2014, we had some funds with LDWF, and a lot of people at the Fisheries Research Lab in Grand Isle worked long hours and really hard to do a lot of trolling across the Louisiana shelf. And I thought that this would be interesting because although it's an older data set, we're all going to be talking about where flounder go when they go offshore, how they spawn, all that kind of stuff. And I don't have sex information with this, but we did catch flounder in that survey. And I thought it was interesting. So all the little blue X's is our effort. So that's everywhere we trawled during this period. And then you can see we only caught about, at max, 3 southern flounder in one trawl, but you can see where they're kind of concentrated around the river mouth. Now, sampling stations were also concentrated around the river mouth just from a function of depth strata being concentrated, but you can see where the catch is, and this is even more interesting, although I was informed by Mike Dance this might not be that interesting, because he was saying that he knew that they stayed offshore. But I just thought it was interesting with the season, how you had, summer, spring, summer, fall, winter, you had flounder offshore the whole time. So I thought that was really cool. So positive catches of flounder from that trawl survey. And then again, effort represented in the blue axis. All right, so with all that, I'd like to acknowledge all the Fisheries Research Lab staff and management. Joe West helped me a lot with some of the data idea processing. And then Gulf Coast Research Laboratory, thank you to, obviously Nancy was the author on this, but also Robert Leaf, Morgan Corey for their data. And then the Gulf States Marine Fisheries Commission, IJF. Any questions?
Might have time for one question. I've got this one over here.
Sorry, guys. Took my time.
It's okay.
Eric, George Malonzo, Wildlife and Fisheries in Lake Charles. When y'all were doing the trawl samples for the during the summer months of 2014 or whatever it was that you showed the data, did y'all differentiate sex of the samples, the flounder samples?
They did not. Yeah, I was going to have Clint answer that for you because I really asked him before I did this. But yeah, no, they did not. So that was a bummer. But they were doing so much. So yeah.
Okay, cool.
But they did have some lengths. You'll have some length data in there. So.
Thank you, Eric. Next up, Nicolette Beeken is going to talk about spatiotemporal trends in hatch and metamorphosis timing in Texas. The floor is yours.
Hi, everybody. So yeah, I'm Nicolette Beeken with the Texas Parks and Wildlife Department. I'd like to start with acknowledging 2 of the co-authors on this manuscript. So that's Joel Anderson at the Periyar Bass Marine Fisheries Research Station and Dr. Mark Fisher at the Rockport Marine Lab, also with the Texas Parks and Wildlife Department. So I guess to start, just speaking broadly, why is it important to examine early life history events in fishes? Well, studies have shown that key early life history events like hatching and metamorphosis can partly determine larval survival and juvenile recruitment success. Also, we can use peaks in a hatch date distribution as a proxy of the onset and duration of peak spawning. We can use peaks in a metamorphosis date distribution as a proxy of peak early settlement and recruitment to nursery habitats. And studies have shown that increases in water temperature associated with climate change can affect the recruitment timing of harvested species to nursery habitats and ultimately commercial and recreational fisheries. So in our study, we examined spatiotemporal trends among 3 coastal regions and coast-wide across a 39-year time series in average hatch and metamorphosis timing, as well as average water temperature. And then we looked to see how average water temperature related to average hatch and metamorphosis timing across the time series. So as far as the sample collection, young of the year individuals were collected in monthly bag seine samples in Texas bays coast-wide. There was a total of 71 individuals collected over a 3-year period from 2019 through 2021, and these individuals were then used for otolith analysis. And the total length at capture of each individual was measured. So otolith methods were used to estimate the total age at capture in days of each individual. And since these otolith accessory growth centers are associated with metamorphosis and the completion of the larval stage in southern flounder, we were able to estimate both age at metamorphosis and juvenile age. So a little bit about the Texas Parks and Wildlife Department Fisheries Independent Monitoring Program and the database. So this database provides logged catches of southern flounder caught in bag seine and gill net samples. The bag seine samples are monthly and the gill net samples are seasonal with a fall and spring season. The information that we have for each individual includes their total length at capture, their capture date, and their bay of capture. Typically, the bag seine targets young of the year individuals, while the gill net gear can target subadult and adult individuals. Also, this database provides water temperature measured in our bays coast-wide. So we extracted these data for all years from 1979 through 2017, providing us with this 39-year time series. So on these figures here, the total length is plotted on the x-axis. For the figure on the left, otolith-based juvenile age is on the y-axis, and for the figure on the right, otolith-based total age is on the y-axis. So these otolith-based linear regression models were used to predict juvenile and total age for southern flounder between 25 and 119 millimeters total length that are logged in the database. So as a result, we had juvenile and total ages predicted for these young of the year flounder caught in bag seine samples coast-wide from 1980 through 2018. As far as the spatial analysis, this was done at a regional scale. So it included 3 latitudinal coastal regions, the upper, middle, and lower coast, and each region included 3 bay systems. So some of the dates that were calculated were individual hatch dates, and these were calculated by subtracting the predicted total age at capture from the capture date. And also individual completion of metamorphosis dates were calculated by subtracting the predicted juvenile age at capture from the capture date. So for this plot, the percent of individuals that hatch and complete metamorphosis is plotted for each month on the lower, middle, and upper coast. So what we found is for most individuals captured coast-wide across this time series, most of them hatched in October, November, and December, and completed metamorphosis and settled to Texas bays as early as December and January. So what we have here is the average hatch timing plotted for each coastal region and hatch year from 1979 through 2017. A repeated measures analysis of covariance showed no significant evidence of autocorrelation or dependence in average hatch timing across the time series. There was a significant difference in average hatch timing among the hatch years, but not coastal regions. And also here, there was a positive correlation between, negative correlation between hatch year and average hatch timing on the upper coast and coast-wide. So this is indicating that hatch timing is shifting earlier across the time series. Another one here, we have the average metamorphosis timing plotted for each coastal region and hatch year in the time series. The repeated measures ANCOVA also showed no significant evidence of autocorrelation here in the average metamorphosis timing across the time series. There was a significant difference in average metamorphosis timing among hatch years and also coastal regions. And here what we found is that individuals captured on the upper coast complete metamorphosis significantly later on average than those captured on the middle and lower coast. And similar to hatch timing, and not surprisingly because the two events are positively correlated, we found a positive correlation here as well between the hatch year and average metamorphosis, a negative correlation between the hatch year and average metamorphosis timing on the upper coast and coast-wide. So again, indicating that the average metamorphosis timing is shifting earlier in the year across the time series. One more ANCOVA here, except this time we have the average water temperature plotted for each hatch year and coastal region across the time series. In this case, there was a significant difference, or there was a significant correlation, autocorrelation in the average water temperature across the time series. There was a significant difference in average water temperature among both hatch years and coastal regions. So not surprisingly here, the average water temperature was significantly warmer on the lower coast, intermediate on the middle coast, and cooler on the upper coast. And also there was a significant positive correlation between hatch year and average water temperature on the lower, middle, and upper coast. So here we're seeing that and not surprising, this has been shown in other studies in the Gulf of Mexico, but that the average coast-wide water temperature is increasing across the time series. For these figures, average yearly water temperature is on the x-axis, while the average yearly hatch timing is on the y-axis. So what we found here was a significant negative correlation between the average water temperature and the average hatch timing on the upper coast and coast-wide, where, let's go back. Let's see. Wrong direction. Let's see. Whoops, okay. Let's see. I think I'm hitting the wrong one. I'll just give it a second. I've clicked it a few times. Okay, we're back here. Let's go back to that slide. So yeah, we're seeing that higher water temperatures correlate with earlier hatch timing on average across the time series on both the upper coast and coast-wide. So for the plot on the left, hatch year is on the x-axis, and average capture timing in gill nets deployed during the fall is on the y-axis. For the figure on the right, the average catch per hour in gill nets is plotted for each fall week within 4 time periods. So we expected that the shift that we saw toward earlier average hatch timing resulted from a concurrent shift toward an earlier spawning immigration. However, we found no evidence supporting this claim. We actually found the opposite pattern of a trend toward capturing individuals later in the spawning immigration season across the time series. We also found increases in catch per hour later in the spawning immigration season within later periods of the time series. So this is indicating that spawning immigration activity increases throughout the fall. So this is a simplified conceptual model where hatch, metamorphosis, or recruitment timing is on the x-axis, and the percent survival at capture in big seine samples is on the y-axis. In our study, we are proposing that the larval and juvenile survival window is shifting and or narrowing across the time series. And at a coast-wide scale, our model and alternative hypothesis predicts that years with lower bay water temperature correlate with higher survival and recruitment of individuals that hatch and recruit later in the year. In contrast, it predicts that years with higher bay water temperature correlate with higher survival of individuals that hatch and complete metamorphosis earlier in the year. On this plot, the minimum yearly nearshore water temperature is on the x-axis, and average yearly metamorphosis timing is on the y-axis. So these water temperatures were measured in the Gulf of Mexico at most 10 miles from the Texas shoreline for each year from 1985 through 2017. And these minimum water temperatures occur in the winter months, December, January, and February, approximately during peak months of metamorphosis. And we found that let's see here. We found that a lower minimum or winter water temperature correlates with later average metamorphosis timing across this time series. So some key findings from this study is that the young of the year individuals collected coast-wide show similar hatch timing. However, on average, young of the year individuals collected on the upper coast complete metamorphosis 8 days later than the middle coast and 12 days later than the lower coast. And this appears to be partly from exposure to lower winter water temperature in the Gulf of Mexico as larvae. We also found on the upper coast and coast-wide a shift toward earlier hatch and metamorphosis timing across the time series, and where the higher bay water temperature correlates with earlier hatch and metamorphosis timing. And then overall, we found increasing coast-wide bay water temperature across the time series. So importantly here, what are the ecological implications of this study in Texas and the Gulf of Mexico? Well, our data suggest water temperature dependent variation in the survival and recruitment of young of the year individuals with either early or late hatch and metamorphosis timing. We've proposed two potential mechanisms for the appeared higher mortality of individuals that hatch and complete metamorphosis later during warmer years. One being that hatching and completing metamorphosis later in the winter exposes larvae to colder than optimal water temperature. The other being that later metamorphosis and recruitment to the bays in the spring can expose juveniles to higher than optimal water temperature. So these results can be used to predict how future changes in Bay and Gulf of Mexico water temperature can impact the survival of individuals that hatch or complete metamorphosis earlier versus later. And lastly here, management implications in Texas and the Gulf of Mexico. So we're seeing that in warmer recent years in the time series that the earlier spawned offspring appear to have a survival advantage. At least these are the ones that we are capturing in our Bag-Sane samples. Last year in 2021, Texas Parks and Wildlife Department enacted a complete closure of the flounder fishery from November 1st through December 14th of every year. So we're suggesting that future flounder regulations such as gear restrictions, bag limits, and season closures, and even stock enhancement practices could be enhanced if implemented earlier in the spawning season, like in the month of October. And the take home here is that these earlier spawning flounder could be driving the reproductive success of the population. And I'd like to, again, thank my co-authors that I acknowledged at the beginning of the talk, Joel Anderson and Dr. Mark Fisher, and also the fish and wildlife technicians who collected our samples and logged data on them. Thanks, everybody.
We have time for a couple questions. Nancy's hand is up.
Hi, Nancy Brown Peterson, Southern Mississippi. So, do you have any adult data to go with this? Do you have collecting females that you're seeing that they're in spawning capable earlier in the season, or if you got any immigration data? Because your larval juvenile data is pretty cool, but I'd love to see adult data to go with that.
Yeah. So not in this. Oh, sorry. Yeah. Grab this. So not in this study. We didn't collect adult individuals and then use some of these techniques to identify like the sex or the stages. We could use other studies to kind of make some implications about this stuff. I had a study that was showing size at maturity in Louisiana and Mississippi, and that's what we're using here to indicate that the gill nets can target subadult and adult individuals based on the average sizes that we catch in our gill nets. But yeah, for this study, we didn't log that kind of information. Yeah.
Hi, Kenneth Erickson. I was wondering if you all had any ideas or had looked at maybe why there's that disconnect between them hatching earlier but not necessarily moving into the estuaries and settling earlier.
Yeah, so that was a bit of a shocker on our end, and that is why we wanted to go ahead and look at this gillnet data to see if we could detect changes in the timing of the spawning immigration. And from that mismatch that we're seeing in our data, we're looking at it from the perspective of like survivorship bias. So it appears that the spawning immigration isn't changing, or if it is, that actually the fish are moving offshore later based on the fishery independent and dependent data, but it's the ones that are surviving to the point of being captured in our Bag-Sane samples is the ones that were spawned and hatched earlier. Yeah.
Mike Dance at LSU. My question is kind of similar.
Mm-hmm.
I was trying to make sense of that disconnect. If you had a peak in late October, kind of early November of
Yeah,
hatch
it was
date?
like October, November, and December were the three peak months of of a hatch.
And it seems like the main emigration is late November into early December. So, what do you think's happening there? Yes.
Well, it's tricky, but I mean, we're thinking that there's differences in the survival of the ones that hatch and complete metamorphosis earlier or later. So we're thinking that there's a survival advantage with the fish that were hatched earlier. Yeah, that's what we've got in the manuscript so far as interpreting that mismatch. That was kind of a curveball for us as well. But yeah, survivorship bias is kind of what it came down to.
Okay.
Uh-huh.
Unfortunately, I think we have to keep going. Keep your questions.
Yeah, we
will
can
have a
talk more
collective
later too.
at the
Thanks,
end.
everybody.
Thank you again, Nicolette. 2 more talks before lunch. I know we're all getting hungry, so hang in there. Next talk is Henry Hershey. He's going to tell us about contingents of flounder in
Northern Gulf of Mexico.
Gulf of
Yeah, we've got samples from all over. Thank you, Steve. I'm Henry Hershey. I'm a PhD student at Auburn University. Most of my research is on paddlefish. Some of you have expressed some confusion about why a paddlefish biologist is at a flounder meeting. But when your advisor discovers that you actually like modeling, you become an everything guy pretty quick. So let's get to it. I want to acknowledge that these data came from Adrian Stanfield's master's thesis work. He is actually smiling in this picture, but you can see that the effects of zero inflation have on a man there. His work was funded by British Petroleum, and so he was collecting flounder in 2014 and 2015. So we know a little bit about stock structure for southern flounder, right? We know that the Atlantic stock is genetically distinct from the Gulf of Mexico stock. But there's a little bit of evidence suggesting that there might be some spatial structure within Gulf of Mexico and the South Atlantic. There's wide spatial variation in growth rates, which has been used to suggest that there might be some stock structure. And also, each of the states is managing flounder differently. Actually, up until recently, the length limits were sort of all converged at 14 inches. So the stock structure is really important to understand if they're being managed differently in all the states. So the guiding questions of our research were to try to see if we can differentiate between flounder from three different Gulf of Mexico estuaries using otolith microchemistry. We sampled from Barataria Bay, Mobile Bay, and Apalachicola Bay. And the second question we had was, are there detectable differences in age-specific habitat use as indicated by variation in salinity use indicators in the otolith? So a little background on otolith microchemistry. Elements from a fish's environment are incorporated into the otolith as the fish ages. As the calcium matrix grows year by year, elements are incorporated into that matrix. We can measure changes in isotope concentrations over a fish's lifetime using laser ablation, inductively coupled plasma mass spectrometry. Nailed it. So we could burn a transect across an otolith cross section and measure how different element concentrations vary over a fish's lifetime. Some elements are particularly useful, like strontium or barium. You've probably seen studies on those elements. But we can also measure a whole bunch of elements at the same time and use multivariate techniques to combine that information and look at what I call microchemical signatures. So strontium, what can we figure out from strontium? Strontium levels in the otolith are known to be correlated with environmental salinity in a fish's habitat. In some previous work by Mike Lowe and Troy Farmer, a salinity threshold of about 1.7 millimoles per mole of strontium to calcium in the otolith indicated a boundary between freshwater and salt water in the habitat. So theoretically, onogenetic shifts in habitat use should be detectable by looking at how strontium varies around that threshold through a fish's lifetime. So data were collected in 2014 and 2015 using otter trawls and gill nets in Barataria Bay, Mobile Bay, Apalachicola. Adrian caught 90 fish in each estuary for the otolith microchemistry analysis. He measured salinity at the point of capture, and he extracted and sectioned otoliths, obviously. We used laser ablation to measure 15 different elements across that linear transect, as I mentioned. And then we scaled transect distance to fish age using those interannular measurements so that we could associate measurements with, a specific period in that fish's life. And then we, depending on the analysis that we did, we averaged element concentrations to try to reduce some of the dimensionality in the data based on different segments or different years of life. So here's an example of an otolith transect segment. You burn a transect through the cross section from the nucleus of the otolith to the edge, and then we separated it out by core, middle, and edge. The first 10% we call the core, the last 10% the edge, and then the middle 80% meth is the middle, and then that shows up here divided. But we can also use those annuli in the transect to segment it out as well. So we did some hypothesis testing. First hypothesis, do these three potential contingents have distinguishable microchemical signatures? I used a Greedy-Wilkes test, which is basically like a ranked MANOVA. It tells you which specific elements and in what segments are contributing the most to differentiation between the three potential contingents. Then I used a PCA, which is a dimension reduction technique. Obviously, 15 elements and 280 fish is a lot of information, so we try to reduce that information into interpretable microchemical signatures. And then we used LDA, which is just a classification tool to try to blindly assign fish back to their capture location based on the microchemical signatures that we're detecting in their otoliths. The second question relating to ontogeny, we used a regime change analysis that we borrowed from Jared Crisp's thesis work, which he'll be talking about later in more detail. That's basically a time series smoother. You saw that spiky kind of transect data. We try to smooth that based on like a moving average algorithm, essentially, where it sort of flattens. I'll show you how it works later. The Fisher's exact test then is used to compare how residency classifications based on that salinity threshold vary between the three potential contingents and from age to age to age. So first hypothesis, Greedy-Wilkes test, we averaged values, like I said, within those three segments. So we had 280 fish, 15 elements, and 3 different segments for each element. So that sort of expands the data set even more. So we had 45 variables, 45 columns in the data set. The test showed that the 3 most important variables that contributed to statistically significant differences between the contingents were edge barium, core strontium, and middle strontium. There was a slew of other important variables, but those were the top 3. So the PCA here, you're looking at a loadings graph where the first 2 dimensions are shown. There were more dimensions that contributed to, that explained a larger proportion of the variation. But just for an example's sake here, the edge, you can see like edge copper. It's the top one, the pointer? Okay, cool. Edge copper and edge zinc have a strong contribution on PC1 here. So elevated levels of edge copper and edge zinc. And then PC2, you have elevated levels of that core barium, mid barium, and then depressed levels of vanadium. Essentially, what this is showing you is that these 2 microchemical signatures are kind of, split across these 2 axes. It's just showing you what these axes mean. So when we look at how individuals score along those PCs, we see some clustering, right? So Florida fish, the red triangles, are coming out in low levels of both microchemical signatures, and then Alabama and Florida are kind of mixed up a little bit. But if we look at their scores on all the PCs, all the principal components, and then put all those data into the LDA, we can basically see how how well we can classify a fish based on their overall microchemical signatures. So it gets a little difficult to interpret exactly which elements are contributing to those things, but once you put all that data into the LDA, it's looking at the whole suite of elements in each individual's otolith. I gotta wait till it comes back, don't I? Oh, it's gonna jump ahead. I was told about this already. Come on. That's working. Can you advance it from the computer for me? Okay, so these are the LDA results. I don't know if you're familiar with LDAs, but these are insane numbers. 80 up to 86% classification accuracy. So without knowing where the fish came from, we're looking just at its otolith microchemistry data. We can say with 86% certainty that that fish came from a certain estuary in the northern Gulf of Mexico. Another interesting thing to note is that fish were classified more often as their neighboring estuary than the further one, which indicates that there is some sort of, it's probably spatially linked, right? Proximity is usually a good indicator that things are similar in general. So yeah, I was really excited to see these numbers and show my advisor. So regime change analysis. This is an example of how that time series gets transformed, right? We have the really spiky waveform, time series of strontium, and then it flattens. These are the statistically significant different moving averages. So once it detects a new significant average, it jumps to that average and stays there until it detects another significantly different average and then jumps down there. So you can see it's kind of flattened. Well, if we use this threshold, right, 1.71 millimoles per mole, and draw a line across that transect, we count the number of values in the transect above or below the threshold, and if they're above 90%, if 90% or more of them are above the threshold, that year gets classified as a saltwater year. If it's 90% below the threshold, that's a freshwater year, and then anything less than 90%, if it's jumping up and down or crossing the threshold during the year, then it's a transient year. We have up to 5 years of data for some fish, but 5-year-old fish, really hard to find. So we just limited the analysis to the first 3 years of life. These are the age distributions of the fish used in the analysis. Obviously, old fish, very uncommon in Alabama and Florida, but we have a weirdly high contribution of age 4s in Florida. I think that was probably due to a couple of really lucky net sets or some hints from NOAA about where to go fish. So I'll just talk about the first 3 years of life, that age 0 year, the birth year, and then the second and third years, which are when it's age 1 and age 2. So these are stacked bar charts showing the relative contributions of these different residency patterns in each year of life, and these are statistically significant differences between the 3 potential contingents. So what you can see is that in the birth year, there's a strong estuarine signature, saltwater. Obviously, fish are born offshore, so there's going to be a higher strontium concentration in that core part of the otolith. There's quite a bit of transient signal, especially in Florida. And then the differences in freshwater are interesting, where the Apalachicola estuary fish had a larger proportion of freshwater signatures in that first year than the other 2 estuaries. In the second year, almost the freshwater signature almost completely goes away. And then this is kind of hard to interpret here because we only have 7 fish from Louisiana that had that second year of data. But we wanted to know how sensitive our results were to which threshold we chose, using 1.71 for different estuaries, where because 1.71 was developed by Mike Lowe and Troy in Mobile Bay, we were wondering if we can really apply that to Barataria and Apalachicola. So we used we thought about, since we didn't have any actual water chemistry data, we thought about using the fish as chemical sensors, essentially. If the last 5% of the otolith represents the most recent environmental history, we can use the strontium concentration from that edge maybe to correlate with the salinity at point of capture. So if you run a regression on those data, use the intercept where the predicted strontium level in that last 5% at 0 parts per million salinity at point of capture, then that might represent the threshold point between fresh and salt water. So we did a regression for each of those 3 bays, or the 3 estuaries, and we found that the results are really, really sensitive. So we're kind of scratching our heads thinking about which thresholds to use, and I'm also here to solicit feedback from you guys to figure out if you have any suggestions or thoughts on what to do. There's still, I mean, the overall trends are the same. The Mobile Bay fish seem to have the lowest freshwater signal, regardless of, relative to the other estuaries, regardless of which method you choose. But you can expect a larger freshwater signal when you raise that threshold up, right? Because more of those strontium values are going to fall below the threshold if the threshold's higher. So conclusions, yes, the stocks can be differentiated based on their microchemical signatures. That has implications for offshore sampling. If you go out and you sample a bunch of fish, and you take some otoliths, you might be able to figure out where they came from or where they've been based on their microchemical data. The relative importance of freshwater habitat for age 0 fish might be different between these 3 estuaries. That conclusion is kind of hinging on this sensitivity analysis and what we can glean from our data. But that's obviously really important for growth, like Jared's going to talk about later, when a fish decides to be in salt or freshwater. Strontium variation we observed could be due to spatiotemporal variation rather than fish movement. So I'm really interested to see some movement talks later to validate some of these results. And then finally, future work, we're going to try to quantify the influence of these inferred salinity patterns on growth and try to incorporate these as sort of like a historical reference data set for Jared's work, which was much more recent sampling. So definitely stick around for that. And again, would love to talk to you guys about any strontium data you might have or thoughts that you have about strontium thresholds, maybe using other elements. I might be looking at barium here in a few days when I get home. But yeah, I'll take any questions.
Yeah, this is Fred Scharf from North Carolina. So that was a nice talk, Henry. I was curious about the LDA. And so when you do the linear discriminant analysis, what data is being used is it the entire lifetime signature that's being used to sort of categorize those fish and be able to discriminate?
Yeah, so rather than use 48 variables, or 45 variables, however many it was, we basically just reduced the number of variables that we were feeding into the LDA using the PCA. So instead of getting the edge strontium concentration plus the middle, it's just taking into account the microchemical signatures, the multivariate signatures that have been reduced to those PCA. So it's the PCA scores that are feeding into the LDA. It's kind of like a hierarchical process.
But just to follow up, I wonder if there's an opportunity with the Florida fish, since you had a whole bunch of older fish like age 4s, if you were able to look at the juvenile signature for those fish and if they could have been actually sourced from one of the other estuaries as opposed to the location of capture.
Yeah, so there's a paper, I think 2019, Wang et al. 2019, that did a really cool LDA. I think they actually used quadratic, but it doesn't matter. It just draws a line through it or a parabola through it. I'm going to do like an age-structured LDA eventually, and then also do some cross-validation to see whether we can assign the discriminants from one age class to another age class as accurately.
So on the concentrations, did you use the same instrument Troy used, or?
I didn't use the instrument myself, but I'm pretty sure it was the same one. Yeah.
Okay.
At
I mean,
this-
because that's one of the things. Obviously, when you look at absolute concentrations from anything, the instrument does matter. There's not a whole lot of inter-instrument calibration. You know, when you start using absolute concentrations. So.
Hi, Kim Walsh, LDWF. You said you were going to go back and do it by age class. I wonder if that might help with the strontium thresholds by doing it instead of just a 10%, because for an older fish, you're going to get more ages, so a greater chance to move variables. And if you do it by the age, that might help smooth that out.
Yeah, the trouble with the reason that we chose for the Greedy-Wilkes test and the PCA to split it by core middle edge was because of the imbalance in the age classes. We didn't want to have, 5 strontium variables for one fish and 3 for another just because it was younger. But yeah, that's a good point. All right, thanks. Don't tell your advisors you like modeling.
Thank you, Henry. I will introduce myself here. I'm Steve Midway at LSU, and my talk is titled Life History, Variability in Southern Flounder. This talk will be a little bit different, a little bit lighter on data, and a little bit heavier on ideas and conceptual approaches to merging all the life history estimates and the variability that we see from the talks we've seen this morning, talks in the literature, etc. Before I do this, though, this doesn't happen without a number of people. Fred Scharf, probably the originator of a lot of the conversations I've had that led to this work. Ty, Steve Arnott, Patrick, Fernando, Tom were all co-authors on a paper, which I'm going to introduce parts of later, as sort of a case study for the concepts and ideas. And then Kenneth Erickson, who's a student of mine who helped out with some of the life history and variant stuff that I'll close with. And of course, data provided by a number of agencies. The case study we'll go through is actually not a meta-analysis in terms of using the results, but actually reanalyzing all the data. So a heavy hand from agencies being able to provide that. And of course, Louisiana Sea Grant supporting much of this work. So a quick background on life history theory. Many of you know this, but it dates back to about the mid-20th century, and it's somewhat of a response to this idea of evolution is driven by genetics. Once we figured out what genetics did, that was sort of our solution or our way to address evolution, but yet a number of folks rightly said, but the way the organism responds to its environment is also a thing. It's also very important. These whole organism traits are important. Trade-offs are a central theme, right? You can improve in one dimension of a life history trait, but it's likely going to cost you in another dimension. And there you see a picture of Stephen Stearns, one of my favorite quotes about life history theory, suggesting that life history theory visualizes the design of an organism as an evolutionary solution to an ecological problem. And of course, life history theory and traits give us the tremendous diversity and variability that we see in fishes, from incredibly large sizes to small sizes, old fish, centuries old, to fish that live only a few weeks or months, and offspring in the single digits of fecundity up to millions, if not greater numbers of eggs. How do we measure these life history traits? We often talk about age and size of maturity, fecundity or number and size of offspring, the frequency of reproductive events, longevity, natural mortality, there's many more. Oftentimes you'll see they're clustered as well, or they're sort of modeled together because they co-vary. You know, if you live longer, you likely have a larger size of maturity or an older age of maturity, and so forth and so on. And the image you're seeing here is one of Kurt Weinmiller's, I think originating from some work with Kenny Rose about a decade earlier, looking at these traits in sort of a trilateral model. What is the importance of understanding life history traits? Well, going back a slide or two ago, natural selection is based on survival that is determined by these combination of traits that individuals and species adopt. So there's an ecological and an evolutionary importance to it, but for this crowd and today, we think of it more because it helps determine population dynamics, which may or may not, usually it does, influence stock assessments, and also relates back to regulations. We're all familiar with, you know, a size regulation, and of course, growth and size is a life history trait. So we deal with these traits all throughout fisheries science, and they're very important for us to understand. However, the traditional or conventional way that we've estimated traits tends to be more of a point estimate or, you know, a single study type of approach. Here you see just sort of a cartoon of a von Bertalanffy growth looking at age and size of individuals, and that typically is applied to one data set. So we take a bunch of fish we've caught, we age them, and we look at how large they are, length, weight, and we model that, and we say, here's our von Bertalanffy, here's our growth coefficient, here's our asymptotic size for this population or subpopulation of fish. Similarly, we do that with maturity. We've seen a number of maturity ogives this morning. This is a version from a paper Fred and I had several years ago looking at the proportion or probability of being mature over different sizes. So we're all familiar with these. They're throughout the fisheries literature. However, to quote what I think is an underread study of John Honig and co-authors from about 6 years ago, there's little guidance on how to conduct comparative life history studies and how to evaluate them. So we're really good at applying these life history analyses and models, but we're not really good at looking at them from a larger holistic scale. Is there evidence for intraspecific trait variation? Yes. There's not much of it because we haven't done a lot of it. We haven't looked a lot, but there is evidence for it. Many of you are familiar with this Flatfish's book, and I'm going to pull a little bit from that. The chapter on life history traits, there's a quote in there that data on interspecies variability are available for only a few flatfish species, and the data are quite limited in most of these cases. So basically, we don't have the data and or we haven't looked. But in those few instances where we have looked, latitude tends to be a major driver, no surprise. Light and temperature, master variables, they're kind of baked into latitude, and latitude's an easy variable to measure. So that shows up as being important. The L infinity and K parameters coming from that von Bert often decrease with increasing latitude, just sort of a general trend from this chapter. And growth rates are also reported to increase toward the equator. So, you know, you can kind of pick and choose from the limited amount of synthetic material that has been done on this, what you want to determine. Going back to the Honig paper, the other quote that kind of hooked me in was that the hierarchical nature of the data warrants consideration. And I'd actually been working on some of this stuff prior to reading the paper, so this paper was sort of scratching me right where I itched. And it helps me to understand ways that we can take the covariance and the nested and relatedness of these different parameters and learn something from sort of the sum instead of just the parts. So the quick conceptual model of this is, what do we know? We have individual studies, and I think of them as puzzle pieces, right? A von Bertalanffy model for this population, age of growth for that population, whatever the trait is, whatever the estimate is, we have a bunch of pieces. And what we want to do is infer larger patterns from that data by figuring out how they work together. You know, we don't really need to see the individual piece. We want to see the larger picture. So the two questions that this sets out to address are, can we use hierarchical models to quantify relationships within a life history trait such that a macro scale covariate or covariates can be identified? We'll talk a little bit more about what that means. And the second question is, can we use relationships among life history traits to sort of bootstrap, and should probably have that word in quotes, but bootstrap estimates for understudied life history traits, or those traits that we don't have a lot of puzzle pieces for. The approach brings into the mix this idea of a cross-scale interaction, which unfortunately I'm not going to have much time to talk about. If you're interested in these things, I highly recommend this paper. It's a paper by Pat Serrano et al. From 2014 that outlines this conceptual model and goes through examples of cross-scale interactions. For our purposes, for fish people, for fish studies, we think about cross-scale interactions as building on what is the typical local response that we look at, abundance, a life history trait, et cetera. We often think about what is that immediate or local driver, and we often neglect to think about what is that regional driver and how does it modify the levels below it. And then a CSI is really getting at how can we quantify all these things in one way or one model. So we'll get into this case study with flounder growth. The question here is, are there macro scale patterns of growth among southern flounder stocks? So what do we know going into this? We know that southern flounder have variable growth, no question there. It's likely linked to early life, which is also location. Those two are extremely collinear. And that there have been growth studies across the range. So we have some puzzle pieces to work with. This is a table from that paper. And you can see life history estimates or I should say, growth parameter estimates are somewhat across the board here. If we look at males in the Carolinas, neighboring states have quite different estimates of K. If we look at females in the Gulf, females in South Carolina versus Texas, extremely different estimates of L infinity. And the question is, are these correct? Are these incorrect? Is there sort of observation error with the measurements or the models? Or is this all system error, state error? Is this error that's coming from the fact that these are entirely accurate, we're just not able to understand why they vary? And this model gets at that. So we start with our out-of-the-box von Bertalanffy. This is not the hierarchical Bayesian version yet, but this is our von Bertalanffy model. And on the right, you can see sort of just a cartoon of what that growth model looks like. The way we make this hierarchical is that we add all of these red J's, primarily to the parameters. They can be added to the data or not, but we won't worry about notation at this point. We add them to the parameters, which allows each of those parameters to vary. So we're essentially creating a varying parameters model in which we allow one model to estimate K, L infinity, T sub 0, whatever that parameter is, can vary for each of the contingents or stocks or subpopulations or whatever that unit is of interest. So the quick result on that study is what you see here. The black dots are observations of fish. The blue line is the global estimate. So that's if you were to just run one model on everything. The red lines are the Atlantic estuaries and the dashed line are the Gulf estuaries. And you're seeing that there's some differences. You're probably thinking there's some overlap, and you're right. We can look at instead the parameter estimates, with the top panel being the L infinity and the bottom panel being the growth rate or growth coefficient. We can look to these and directly understand which of these differs or doesn't differ. For example, with L infinity, Pamlico Sound is quite different from the Cape Fear. But Pamlico Sound is not different from New River when it comes to a maximum asymptotic size. So this model allows for a sort of pairwise comparisons or pairwise approach to looking at these parameter values and actually having some statistical inference on them. But to quote Ron Popeil, there's more. These models can do more than just give you stock-specific estimates. Let's go back to that figure where we have different stocks or different populations that are modeled. Imagine we have 4 stock-specific L infinities. These L infinities can be then treated as response variables in a new regression, I should say a coupled regression, because we're still doing this within the same model. And we regress that against some macro scale predictor. Here we'll pick on latitude. Could be another macro scale predictor, but we might hypothesize that those asymptotic sizes decrease with latitude, and in fact they do in this example. This is the cross-scale interaction, and this is the math behind that. I'm not going to spend any more time on this, but if you do care to learn more about the models or the Bayesian aspect of it, please talk to me. And so the question is, can small-scale variability in growth rates be connected to large-scale drivers? Yes. This is an example of the growth coefficient for male southern flounder across latitude, and we clearly see a significant negative slope of latitude. So for male southern flounder, the growth coefficient decreases as latitude increases. We can actually quantify that. It's about 0.1 decrease in K for every decrease in latitude. It allows us to both interpolate and ask what might that growth coefficient be for latitudes that are unobserved, and it allows us to extrapolate what might that growth coefficient be for populations at latitudes that we didn't include that are outside of our range, of course, all caveats included. This leads to a life history matrix idea that I am working on very slowly, which answers the question, can we use existing trait data and hierarchical relationships to generate estimates or hypotheses for unobserved traits? So how do we take this hierarchical approach and expand it to traits that we just don't have as much information for? And the answer is potentially with life history invariance. So if we think about a trait space that may involve natural mortality, maturity, and growth, we know there's correlation, there's covariation, there's relationships between these. And these are 3 examples of life history invariant relationships. I'm not wedded to any of these. I'm just showing you these are the actual equations that can purport to translate and move you between these life history traits. So the conceptual model for this is imagine a space where we have what I'm calling data anchors or puzzle pieces, empirical studies, whatever you like. It's realistic to think we might have 1 for natural mortality and many more for growth. So what we do is we evaluate a number of invariant equations to build these invariant bridges or hypothesized invariant bridges. Once we evaluate them, because there's typically many to choose from, we can identify the best fitting one or the most supported life history relationship. And when we have 2 traits where we can have enough data to understand the model fit, we can then identify that best supported life history trait. And from there, we can try to expand onto unobserved or understudied traits. So if we don't have that much information on natural mortality, we may be able to use both the macro scale strength and the invariant relationship between growth and maturity to help us predict what the macro scale effect is on natural mortality. This is a quick snapshot of just a small number of invariant candidates. We're not going to get into that, but there's a lot of invariant candidates that can move you around between different life history parameters or life history estimates. The benefits of this is it applies the macro scale variability both within and among traits. It ranks and supports flounder-specific invariant relationships. I didn't get into it, but some invariant relationships are based on butterflies, and some are based on insects, and some are on fish, and some are on all animals. But we can identify which of those are strongest for flounder. Our best guesses can be hypotheses for traits that we're not really observing. And it's, of course, revisable and dynamic. As we learn more, we can revisit things. So with that, this is not a southern flounder, but it's a pretty cool picture. There's lunch waiting, I'm guessing, so the questions will be brief, but I'm happy to entertain anything you guys are thinking. No questions, Fred?
Thanks, Steve. This is Fred Scharf from North Carolina. So, yeah, that was a really great overview in terms of the kinds of ways to think about these life history traits. You brought up the notion in terms of the growth rates that were measured in the different regions and how some of that variability can be observation error. And I wonder if we're if one of the things that maybe could come out of this workshop is to have, we have a lot of the players here, is just to, I have a lot of questions too, and questions for Nancy and so forth on terms of maturity and some of the ways that we're thinking about it and some of the assumptions we're making and timing and all sorts of decisions that we make. And the same thing with growth and aging and whether or not we could get more unified in terms of the observation error so that we can really be confident that the variability we see is not methodological.
Right. Yeah, I'm not sure how to answer that concisely, but I will say that The table that I showed are the estimates from the literature, and that's why I made the point there could be observation error based on how people ran the models, parameterized the models, things like that. The models that I showed in the results and the figures are from a reanalysis. So I only included data that I only included results when I had the actual data and reran all the models. So if there's error, it's applied uniformly across everything. I wasn't modeling point estimates. I was modeling the actual data. Yeah. But a great point, yeah. Sorry, I'll let Steve do that.
Thanks. Henry Hershey at Auburn. Really cool application of the Bayesian framework. I'd love to see your JAGS code for that hierarchical model. If you post it or something on GitHub, let me know. Another question about uncertainty. So those invariant relationships that you're talking about were all fit, with frequentist models. Will you have to rerun all of those models again as well to carry forward the uncertainty and the growth parameters all the way up to the mortality? I'm just wondering if the inference gets blurred if you start mixing frequentist interpretations with Bayesian.
It certainly could be. I mean, it depends on the data availability, I guess. And I really look at those life history invariant relationships as just ideas of relationships. Gotcha. And then you confront it with the data that you have for flounder. And again, there may be a handful of invariant relationships that take a certain growth trait, K, L infinity, and predict maturity, age of maturity, size of maturity. Say there's 5 of those with multiple estimates across that macro scale gradient, like latitude, you can essentially turn that into model selection and say, what's the evidence or strength for invariant relationship 1, invariant relationship 2, and so forth and so on, to try to identify which of those, based on residuals or likelihood, is the strongest fit for flounder.
Have you tested any of it yet?
I've tested it. None of it's published though.
Okay.
Yeah.
I'm wondering if the uncertainty compounds as you move up scale, right?
So it does. If I can quickly go back, and I'll just show you something that I glossed over, even though it was built into the figure. So what you see in me adding these vertical lines is the error from the level 1 regression or from the actual stock-specific von Bertalanffy. So the nice thing about coupling these models together and having them be hierarchical is that you may have those 4 points that create a negative slope of a line, or you may have those 4 points which create more of a flat line, because you could have incredible uncertainty on each of those. And so the hierarchical approach allows that uncertainty at the stock level to be carried into the regional analysis or the level 2 analysis. It usually means it's harder to find a significant effect of level 2, but it's a more honest accounting of things. And when you do find an effect, it's usually incredibly strong.
Thanks.
I think we're out of time.
Cool.
They are waiting for us for lunch. So thank you. Thank you to all the presenters so far this morning. Yes, sir.
Can we leave items in the room?
I would recommend you just go ahead and leave your stuff in here. We'll ask them to lock the doors. I will ask you to go, everybody, if you've registered, you're included in the lunch. It's in the back of the atrium where the breakfast was this morning. At 1:20, 10 minutes before we start the afternoon session, I'd like everybody to gather in the front part of the atrium, and we're going to do a group photo. At 11:20, if you're not there, you weren't at this meeting. That's how it works. We're not going to shoot another one. So at 1:20 in the lobby, and we'll get everybody set up for a big group photo. Thank you.
All right, we are on YouTube. Hope everyone had an enjoyable lunch. I heard a lot of great conversations. Save some of that for the synthesis session tomorrow. But for now, we're going to pick up and finish with our pop dye and life history session this afternoon. Our next speaker is Mr. Dave Smith, who's going to talk about characterizing the flounder fishery in Louisiana and angler-informed options for management.
All right. I'll just leave that there. Okay. Yeah, I usually give this talk to more of a human dimensions or resource economics crowd. So it's nice to have a captive audience of some classically trained fish people. And with that, I'll jump in. My name's Dave Smith. I'm a fish biologist with Texas Parks and Wildlife. And shortly before I began working with TPWD, I was finishing up my graduate research here at Louisiana State University. And today I'm going to talk about the work we did characterizing the recreational fishery here in Louisiana. Before I jump into my talk, I'd like to make a few acknowledgments. The funding source of this project came from Louisiana Sea Grant, and without the data and stakeholder access provided by Louisiana Department of Wildlife and Fisheries, this project could not have been successful. Numerous biologists, economists, and data managers really helped shape our research. So Louisiana Southern Flounder are among the top 3 recreationally targeted species in Louisiana. Combined with spotted sea trout and red drum, they complete that saltwater grand slam. However, the margin between southern flounder and those other major species is pretty wide. However, there's still a lot of interest in catching southern flounder as an add-on while targeting other fish species. And perhaps the best way to describe this fishery comes from a Creole term, lagniappe, which means something bonus or extra that's added alongside an originally wanted item. In southern flounder, like southern flounder in Louisiana, like southern flounder throughout the country, hold an overfish status currently. So the most recent estimates of abundance and recruitment from the most recent stock assessment show the recent estimates at the lowest levels ever reported in the nearly 40-year time series. And these estimates are so low that the stock assessment stated that management actions are going to be necessary in order to recover the depleted stock. So at the outset of our evaluation, we had the understanding that we're dealing with a declining population, and this understanding really helped shape a lot of our research questions along the way. We focused our recreational evaluation on characterizing the trend and seasonality of landings. We wanted to see if recreational landings are correlated to those abundance trends. And we also wanted to get a baseline understanding of some of the recreational aspects. The method that we chose to do this was through utilizing generalized additive models, or GAMs, and they uniquely fitted our data for a variety of different reasons. GAMs are capable of producing nonlinear and complex relationships between responses and predictors. The seasonal annual trends in the fishery were nonlinear, so this was an important component to analysis. Additionally, GAMs produce easily interpreted visualizations of data, like what's shown here in partial effect plots, where these models are, the smooth estimate is centered around an overall intercept of 0, so that positive interactions between responses and predictors are denoted with positive effects, and negative interactions are denoted with negative effects. Finally, this is a very flexible model framework with the ability to handle a variety of statistical distributions as well as account for autocorrelation in the time series. The data we modeled comes from a very robust source in the LDWF Angler Harvest Survey. And this program develops weekly estimates at a regional scale for each of those 5 zones that are listed there in the map. In addition to the LaCreel program, we also were able to analyze hindcast estimates of the prior federal surveys conducted in Louisiana so that we could get an annual statewide estimate that we can compare to current surveys. So what's shown here are partial effect plots for the predictor variable week of the year. And each of these plots are showing the strength of the response, which was landings per unit effort. And you can see that in each of these zones, landings are really oriented around the fall, particularly with peaks in October or November for every single zone. When we look at this on a statewide level, when we aggregate the data, we can see the focus around the months of October and November. Now what's shown here are annual trends with the year the landings occurred as the predictor variable. And 4 out of 5 zones displayed significant declining trends. Just waiting on it to catch up. All right, 4 out of 5 zones display significant declining trends over the time series, with those declines particularly focused on the latter half of those time series. When we aggregate that data, we can see that there's been a decline statewide over the time series, particularly focused on that second half. But when we take a look at those hindcast estimates, we're able to get a picture of the current decline with the context of a much larger time series. And that decline is really focused around the last 5 years of landings data. So with our analysis, we confirmed that recreational landings are declining in Louisiana for southern flounder. We also confirmed the importance of fall harvest within this fishery. So with a better understanding of the recreational fishery, we shifted our focus towards angler outreach, characterizing preferences and behaviors surrounding possible regulation scenarios that may be fast approaching the fishery. And the method that we chose to do this was through a survey of Louisiana saltwater license holders using the method contingent behavior. Now, contingent behavior is a classic non-market valuation approach, and it's used to evaluate hypothetical situations. In our survey, the hypothetical that we presented were proposed regulation scenarios. And we asked survey respondents what their expected coastal angling effort would be if that proposed regulation scenario was adopted in Louisiana. Essentially, there's three answers to this question. Either your effort can remain unchanged, your effort can increase, or your effort can decrease. And what we're after is quantifying this response so that we could later combine that effort change with a per trip economic value that we calculated using another non-market valuation technique so that we could get a dollar value on each of the regulation changes we proposed. Southern flounder regulations in Louisiana are among the most liberal throughout the country, with a creel of 10 fish, no minimum size limit, and no seasonal applications in the fishery. The regulation scenarios we presented to respondents were regulations for southern flounder that were held in neighboring Gulf states. Now, I know that some of these regulations have since changed since our survey execution, but this is what they looked like in the fall of 2019. In addition, we also presented an exploratory scenario, which was never seriously considered by fishery managers in Louisiana. We simply wanted to see what types of regulations anglers supported and what types of regulations anglers opposed. I'll use these diverging bar charts to show the levels of support and opposition for each of these scenarios. And I'll also use the term net preference to show the directionality and support of each scenario. Net preference is simply the combined percentage of respondents that supported the scenario subtracted by the combined percentage of respondents that opposed this scenario. The most supported regulation scenario was actually not current regulations in Louisiana. It was the Mississippi, Florida regulation scenario, which adds a modest size limit to the fishery. By far, the least supported scenario was the creel addition scenario, with the only negative net preference. And it's important to note that these more restrictive scenarios, like the Texas and Alabama scenario, didn't receive as much support. However, these are strongly positive net preferences, with significantly more respondents that support these regulations than respondents that oppose these regulations. So what's shown here is our contingent behavior with the mean effort change per respondent. And the important thing to note here is that none of these changes were significantly different from the status quo of current Louisiana regulations. Additionally, error estimates around each dollar value change were all within a net zero effect. So the results of our survey showed that Louisiana anglers they support regulations that are currently held in neighboring Gulf states. Also, our survey displayed that coastal angling effort is likely to not significantly change with any of the regulation scenarios we presented, displaying evidence that the strong economic values of coastal Louisiana angling are going to remain intact if any of those regulation scenarios were adopted. So in conclusion, southern flounder are declining in Louisiana. This is evidenced by not only fishery independent data, but it's also evidenced by fishery dependent data. Data we collected can be used to help inform approaching regulation changes in the fishery, the better understanding of the recreational fishery, as well as the behaviors of the anglers that utilize the fishery. And finally, the framework we built can be utilized in a lot of different ways, not just centered around Louisiana southern flounder, but it can be used to develop sustainable management strategies for declining species across the board. And we can use this technique to develop management plans that are not only biologically sound, but also inclusive of meaningful stakeholder engagement. So if you'd like to take a deeper look into some of the methods we used in this study. I'd encourage you to take a look at these two recent publications. And with that, I'll take any questions.
Got one back here.
I'm David Norris from CSA 5 here in Louisiana. And this question actually comes remotely from one of my coworkers who's watching the YouTube. She wanted to know what was the nature of the survey. Was it like phone, dockside, mail? And then what was the response rate from that survey?
Yeah, it was an online survey. We did it through Qualtrics and sent it out to the emails that we had listed for saltwater anglers, and our response rate was roughly around 10%.
And did you see any differences among the different basins with those responses, or was it pretty uniform across the coast?
You know, that's something we didn't look at, but there were people in the Calcasieu Basin definitely were more likely to fish for southern flounder. But as far as response rates go, I don't have that on a basin scale.
Thank you.
Hey, great talk. Shelby White, North Carolina Division of Marine Fisheries. I had a quick question about your contingent valuation methods. Did you only give the anglers the chance to pick between the regulations, or was there an option to maybe not target flounder anymore or switch to another species?
No, the contingent behavior portion was all focused on coastal angling effort and seeing how that changed in relation to regulations. And we also asked them that same question if we did nothing. So we didn't really put that portion in that they could target other species, but it's definitely something that was likely to occur because we didn't see a change in coastal angling effort, but so they're still taking those coastal angling trips, so they probably are going to target other species.
Okay, thank you.
Got time for maybe one more? Okay. Thank you.
Dave forgot to mention that the 3 fish that were held up in that last picture were about $200 each because we paid $600 for a fishing trip and caught 3 flounder. So huge economic impact on those fish. Next up, we have Quentin Hall, who's going to talk about the effect of nighttime guide gigging on flounder in Texas.
How's it going, everybody? My name is Quentin Hall, and I work for the Center for Sportfish Science and Conservation at the Hart Research Institute, located at Texas A&M Corpus Christi. That is the longest and most drawn-out introduction I think any of us have had. I'd like to thank my co-authors on this, particularly Mark Fisher with Texas Parks and Wildlife. There was some data that he was able to provide that really made this possible. And as we already have addressed, we basically got bored during COVID and started trying to figure out what kind of impact recreational fishing is having on Texas's southern flounder populations. All of this is going to be published relatively soon in PLOS One. By the way, I'm pretty sure all 3 reviewers are in the audience right now. So reviewers 1 and 3, I'll buy you a beer, but reviewer 2, don't ask. So I think we've already established there is a decline going on across pretty much the eastern seaboard and the Gulf Coast as well. Texas Parks and Wildlife has shown this decline going back 30 years, and I know there's a lot of contention around this data set due to the gear type, but there are just so many different data sets that are unrelated that show the same trend. I think we can all agree that this fishery is in trouble. I think we can also agree that a lot of the theorized contributing factors like increasing bay water temperature are absolutely playing a role in this decline, definitely reducing recruitment, and then also masculinizing the population as sex is determined by temperature. The issue for us is while we agree that these are all contributing factors, over the short term, there's not a lot we're going to be able to do about increasing bay water temperatures and stuff like that. That's a much longer term problem that we're going to have to deal with. So we decided that we really needed to start investigating some realistic short-term and long-term solutions for the flounder fishery in Texas. And so one of the things that we started pondering was what could be driving the decline. And what we started noticing is that recreational harvest could absolutely be contributing to this problem. This is one trip, 75 flounder in this picture. And this was harvested by one guide on one night. It was actually, there's a backstory to this picture. It was a family reunion, and there were 17 people. And this guide would just roll up to the dock, put 5 people on his boat, go do a trip, come back, pick up the next 5, and so on and so forth. And was able to harvest 75 fish. It bears mentioning that that's not illegal. There's absolutely nothing wrong with this legally. So one of the other problems with Texas's southern flounder fishery is just how complex it is. And I think a lot of other states are in a similar situation as we are. You've got the commercial side of things, which there's a lot of great commercial data available through Texas Parks and Wildlife. And then you've got the recreational side of things, and that's where things really start getting tricky for us. You've got the daytime fishery, which is further divided into private and guided sectors. And that is basically, we have a pretty good handle on what's going on there because of the daytime creel survey program. However, that's mainly a rod and reel fishery. And then you've got the nighttime sector, which once again is private and guided. And there's virtually no creel data available for this because the state only operates during daytime for a number of reasons. And then this is the gigging fishery. And that's important because gigging is a primary harvest method for both private and guided folks. And I'm going to go out on a limb and saying it's not just a primary harvest method, but I would say that outside of Galveston, it is the primary harvest method in Texas. This is further compounded by the fact that gigging boats are more effective than traditional wade gigging, and they are becoming more efficient and much more common. So if we know that all this is a problem, and we know this has been going on for 30 years, why haven't we done anything about it? Well, there's actually a lot of reasons for that. First of all, safety concerns, monitoring boat ramps at night. I don't know if you guys have had the pleasure of being at a South Texas boat ramp at 3 a.m., but it looks like a scene off The Walking Dead. In addition, the daytime creel survey program is already a huge financial undertaking. And basically, if you were trying to develop a nighttime version of this, you're going to double your cost. You can't just pull that kind of money out of your back pocket. So there's really not an easy answer for this. So we got to thinking again, okay, this is all bad news. What can we actually estimate now? And for the nighttime private gigging fishery, there's really no way to estimate that for us, at least that we could find. Hopefully somebody can figure that out. That's a lot smarter than me. In addition, we looked at the nighttime guided, and while there's no official data set, we did find that many nighttime flounder gigging guide services will post client harvest pictures on social media as a form of advertisement. And these are, I mean, they're just as good as creel surveys. They contain a plethora of info. These are examples of some of the types of pictures we would see. And from these pictures, we can determine the number of annual trips, seasonal pressure, client party sizes, annual harvest rates, party limit success rates, and ancillary species harvest. Like in this top picture here, you can see there's actually several sheep's head that were also harvested with the flounder. So just to start off on the right foot, it bears mentioning that these guide services are operating within the law 100% of the time from what we can tell. And that the gigging boats, for the issues they do pose to the fishery, they also do provide public access to the fishery for certain demographics of folks like young children, elderly, and folks with limited mobility that may not otherwise be able to access the fishery. There's actually multiple pictures where folks that were actually in wheelchairs were actually on these boats gigging fish. So that's an important thing for managers to consider. It's really easy to say, oh, these gig boats are the problem, we need to outlaw them. And that's not entirely wrong or whatever, but at the end of the day, they do provide access to the fishery for some folks that would otherwise have a difficult time getting there. So we were able to find 3 guides. It's a small sample size, but it's the best we could do, that had enough pictures posted that we could actually get usable data. And more or less, there was about 1,400 trips we were able to survey off of this, spanning over almost 3-year period. And there was a bunch of metrics that we were able to generate off of that. The real big one for us was that these guides are going on 55% of the nights that are available to them. And in addition, they're harvesting a party trip limit, meaning that all of their clients are harvesting the maximum amount limit between 95 and 98% of the time. So these guys are incredibly effective. We kind of put that in perspective. Imagine if every redfish and trout guide was capturing a limit 95% of the time and retaining it. That would put an enormous amount of pressure on those fisheries. So we were able to break down the number of trips per guide per month. And what we found was that most of the trips are actually occurring in May, June, and July. And this is really surprising because as most of us, have always thought of fall and winter being the prime floundering seasons, and that's just not the case. Most of this pressure is occurring during the summer. And the number of harvested flounder kind of mirrors that. June and July were definitely the highest values across all 3 years. And that also is for the average number of fish harvested per trip. These guides are harvesting between 18 and 20 fish most of the year per trip. And in Texas, the commercial limit is 30 fish. So they're harvesting a little bit below the commercial level. But where this gets really interesting is that there's a lot of ancillary information showing that these guides are taking 2 to 3 trips a night, which is legal. There's no cap on the number of trips they can take per day. So in some cases, these guides are harvesting, up to 80 fish a night. So one of the other things that we really wanted to determine was how many of these guides are actually operating in the state. There's no official record on that, and that's a really important number that we're trying to kind of get a beat on. And we were able to find 21. And we already know that that's an underestimate. We found several more since this analysis was run that are major players that are going on an almost nightly basis. But across the board, there were some trends that were pretty consistent. This graph is a sensitivity analysis from 2018. But like I said, the trends are similar in 2017 and 2019 as well. The 3 guides that we actually surveyed through these pictures harvested more fish, more flounder, than the current daytime guided estimate for the entire state. So that's pretty impressive. In addition, if every guide operates on that same level, it would take less than 4 guides to match the amount of fish that are being harvested for the commercial fishery. And that's pretty nuts. And then the thing that was really astounding is that it would only take around 15 guides operating on this level in the state to equal the total harvest for the daytime private fishery. So there's obviously a lot of problems with this data set. It's small, it's only 3 guides, it's only 3 years, we know that. And we've addressed those assumptions as clearly as we can. But this should definitely start getting folks thinking about the amount of pressure that the private fishery and the guided fishery are putting on flounder in the state of Texas. And this is a crucial data gap. In addition, we found that there were a lot of ancillary species harvested during this time, mainly sheep's head and black drum. There were a couple other species that were harvested like pompano and alligator gar, but not in any real, significant numbers. One thing that we noticed with the ancillary species harvest is that, at least during this study, there was a 2 flounder bag limit between December 1st and 14th. And during that restricted flounder season, effort on other species tripled. So basically, people are not willing to pay $600 or $800 to go out and kill 2 flounder. They want a full 5. So in order to entice people to continue going, they're going to put you on a bunch of black drum and sheepshead as well. In 2021, the new regulations put a 0 flounder bag limit from November 1st to December 14th. And as we expected, gigging guides are already shifting effort to ancillary species with a very high success rate. This is actually a guide located in our backyard in Corpus Christi that we didn't know about until after we had run this analysis. So this is one of the guides that we missed. And as you can see from this post, which is used as an advertisement, he's saying in the past 6 weeks, while flounder have been off limits chasing drum and sheepshead, they've been able to gig around 700 fish with limits every night, and the rest of his December is booked. So obviously sheepshead and black drum numbers in Texas are incredibly robust right now. They can handle that kind of pressure. It just needs to be something that managers think about moving forward. If you start restricting the number of flounder that are being harvested in the gigging fishery, that pressure is going to go to something else. So putting all this together, the nighttime guided recreational harvest is probably comparable to the daytime guided and commercial harvest combined. It has never been estimated until this study. Obviously, we've got a lot of work to do actually dialing these numbers in. We know this isn't perfect data, but it is the best we've got. And then the other thing that is really something that we need to focus on is estimating private gigging effort. There are a ton of folks out there that do this, recreationally that are not running a guide business, and they're putting a significant amount of pressure on this fishery. And we just need to figure out how much. And obviously, I think everybody would agree that we need nighttime recreational harvest data to help inform future management. And that goes for recreational, private, and guided sectors. And then just a couple other things that will probably take a lot of thinking on how to get this info. We need to get more information on gigging boat efficiency and use. 40 years ago, 30 years ago, flounder gigging, you had to wait till October and November when they were schooling up and moving offshore in the passes, and you got a little Coleman lantern and a spear, and you went out there and you may get, 2 or 3. These gigging boats are going out and slamming 4-man limits every night, multiple times a night. So it's a very different fishery now than it was several decades ago. In addition, we need to get a hard number on how many gigging guides are operating in the state. And then we also need to get an idea of how many private and guided gigging boats are in the state, because the gigging boats are where the majority of this pressure is coming from. We're really excited and proud to partner with Parks and Wildlife for an upcoming study that is set to kind of evaluate the use of nighttime creel surveys in a limited capacity, and then also develop and standardize some visual net surveys. And then also, and someone else talked about this earlier, is trying to establish when flounder are actually migrating. It's changed a lot, even in the last 10 years. These fish are going out later, they're coming back earlier, and the traditional seasons are not lining up with what is happening. And with that, I will take any questions.
Check. Okay. Thanks. 2 questions. Are the guides that you're familiar with using public boat ramps? And 2, can you describe the creel survey that you're going to implement, the nighttime survey? Or you can use boat counts with a camera, or?
So yes, they are using public boat ramps. And we have looked at the use of trail cams at boat ramps. I think that will be implemented. We haven't set exactly what we're going to do yet. That's on the table. But for sure, part of it will be actually boots on the ground at boat ramps in the middle of that Walking Dead set. So
It'd be hard to interview zombies.
Yeah, I know.
Yeah, this is Fred Scharf from North Carolina. So one of the potential biases is that for the gig guides posting pictures on their website, right? They have an interest in potentially showing that they catch a lot of fish because they're using that as an advertising campaign to bring people in. Do you have any sense for how much that could be occurring, where they keep a bunch of flounder in the freezer and every time they take a picture they're just pulling out some of the same fish? And is there any way you could actually test for that?
No, there's really no way we can test for that. I will say, going through these picture by picture, you're seeing clients change. You're seeing, different faces, different people. You're seeing the boat ramps change. You can tell the scenery, they're moving locations. I'm familiar with a lot of these boat ramps. They're not near anything where you could keep fish in a cooler easily. It is definitely a potential bias for sure. Is it one that I think is, are they really doing that? I doubt it. And in addition to that too, you're seeing these guys taking multiple trips per night with 15 different people. It would just be very difficult for them to actually pull that off. And you are absolutely right. We're very aware, and we've tried to make it very clear in the manuscript. There are a ton of biases with this kind of data, and we've tried to really outline it. And I mean, this is one of those things we're trying to get the ball rolling. This is not a data set that isn't, we should make a management decision based off of this alone. That's not what we're saying. All we're trying to point out is that these sectors of the fishery are probably the primary harvest, or where primary harvest is occurring, and they're more or less totally unaccounted for.
You may have said this in your presentation, but did any of those 3 guide services know you were harvesting data from their social pages?
No, it's public, and we actually had a team of folks look into legality and keeping everybody anonymous, and we've been very cognizant of that. So you'll even notice the pictures in this presentation were not even taken off of social media. So we've been threading the needle with that. We've been very, very careful.
Gotcha. I was curious if they ever get the report would make its rounds, go, wait a minute, that looks like my dad.
Yeah, no, none of the pictures are going to be public. We tried very hard to keep their names out of this.
John Maresca, Alabama Marine Resources. In your survey, are you thinking about looking at discard rates since these are guided tours?
I don't know, and the project that we're spearheading with Parks, I'm actually not heading that up. Dr. Kesley Gibson with our lab is. That's something that we should bring up to her. That's a good point.
Nancy Brown Peterson, Southern Mississippi. Do you have, since you've got these beautiful pictures, do you have any idea of the length distribution? Are they all just right above legal size, or are you getting like doormat flounders there in the middle of the summer?
That's an excellent question. Unfortunately, a lot of these pictures are such poor image quality, estimating lengths. We actually tried to do this, and we just gave up on it. Estimating length is virtually impossible. I will say across the board, you do see a pretty good distribution of sizes. You do see, doormats coming in pretty consistent. And then you also see, your average, 3 to 4 year old fish coming in pretty consistent too. But in terms of actually delineating exactly what size they are, we couldn't pull that off, unfortunately. Looks like I'm out of time. Thanks, guys. Appreciate it.
Thanks so much, Quentin. Next up, Laura Lee from North Carolina is going to tell us about the assessment in the South Atlantic. Thanks, Laura.
Okay. Still on? Okay, great. I wanted to thank our organizers for allowing me to invite myself to this and talk about the stock assessment. I also want to acknowledge my co-authors who are both here today and will probably answer most of the questions. Mike and Ann are our FMP co-leads for Southern Flounder in the state of North Carolina, and I'm the stock assessment program manager. Okay, so a ton of people contributed to the stock assessment, and we tried, I hope we caught everyone on this slide. There's just a huge collaboration among states, agencies, universities, and other organizations. I especially want to point out Shanae Allen and Amy Flowers. She was Amy Comer then. She's now Amy Flowers. Shanae works for the state of Florida, and she did the first coastwide stock assessment for southern flounder that we did. She really did the modeling for ASAP. She did the bulk of that work. And then when we did the update, which I'll be talking about today, Amy Flowers, getting confused. Amy Flowers, she did that work. So and she's now with the U.S. Army Corps of Engineers. Okay, as you all know, you've seen most of this. I'm just going to review it again. So we know that southern flounder are demersal species that occur in marine and brackish water. They occur in the South Atlantic and Gulf of Mexico, and we've learned today that from tagging and genetic studies, and also from morphometrics that Fred talked about today, that we have two separate stocks delineated by the purple line there. See if I get this work. There we go. And so we have a stock in the South Atlantic from North Carolina through Florida, and then we have our stock in the Gulf of Maine, which may or may not have substocks. We have different dimorphic growth between males and females. Also, we're estimating our female length at 50% maturity at about 16 inches, and this is the estimate we used in our stock assessment model, so that's about 40.6 centimeters. Okay, we've also seen this slide again today, so I apologize for the repetitiveness. I'm sure it's not the last time you will see it, but here we have, this is just depicting the life cycle. You know this, so I'm just going to skip over this slide. I won't repeat it. Okay, so in North Carolina, we have fishery management plans for our important commercial and recreational species. And we review these management plans every 5 years. And the start of that review process is a stock assessment, if we can do one. And so we completed assessments for southern flounder in 2005, 2009, and 2014. And what they all had in common is that we assumed that North Carolina was the unit stock, just the southern flounder occurring in North Carolina. Something special, a difference between the 2005, 2009, between those two earlier assessments and the later 2014 assessment is a difference in how we do the peer reviews. So in 2005 and 2009, the peer reviewers were selected and sort of did a desk review. We just sent it to them through email and said, hey, review this with like no guidance, no structure. Just tell us what you think. Starting in 2011, we formalized that process and gave the reviewers a terms of reference. One of the most important terms of reference is do you feel that this assessment is a valid basis for management for at least the next 5 years? So, and that's sort of what we considered as the pass-fail question for our assessments. So, all of those assessments concluded that the stock was overfished and overfishing, but the reviewers of the 2014 assessment didn't feel that it could serve as a valid basis for management because of the definition of the unit stock. Now, the division is the one that actually gives the pass-fail, but it would be very rare for us to give a different opinion than what the peer reviewers suggest or recommend. So, because of this definition of the unit stock, the assessment failed. Okay, so, and the recommendation was to expand the unit stock based on what we know about genetics and tagging and morphometrics. So, what we're calling the January 2018 stock assessment, as I mentioned before, is a pooled effort among multiple state agencies: North Carolina, South Carolina, Georgia, Florida, universities. We included fisheries dependent and fisheries independent data, which I'll describe in more detail in the upcoming slides, from throughout the South Atlantic. And so another change that happened to our peer review process in 2017 was that December 2017 peer review was our first in-person peer review, where we actually brought them to a hotel like this and had an open dialogue between the modelers and the peer reviewers so we can really get at what we felt was the best model for the stock. So it worked really well, and that's what we've been doing since, except for that little COVID issue when we had to go back to desk reviews and webinars. Okay, so at this peer review, the panel accepted the final assessment model, and so by accepted I mean they considered it as a valid basis for management for at least the next 5 years, and the division agreed with that. But they said that acceptance was based on two conditions. One was that assessment was, the terminal year was 2015, and this was now 2017, and they said, well, if you can update this through 2017 because of all the concerns with the stock, that would be a good thing to do. Not only that, there were changes that you're probably familiar with to the recreational data, the MRIP program. So they wanted us to incorporate those changes because there were big differences in estimates of recreational catches. So we made those updates, updated through 2017, changed the recreational catch data to the most recent estimates, and that updated model is what I'm going to be presenting here today. So here is a description of the model structure on this slide. We're now calling the unit stock North Carolina through the east coast of Florida. We base it on a calendar year, starting in 1989. The reason we chose 1989 as the start year was because we included shrimp trawl bycatch, and that was really the earliest year that we could develop reliable estimates, or that we felt we could develop reliable estimates without doing any kind of pine casting. And then, of course, 2017 was the most recent year for which data were available. We assumed a birth date of January 1st. Sexes were combined, so it was not a sex-specific model. We chose age 4 as a plus group because we really aren't seeing fish older than age 4. So it's just a convenient way to organize the data. Natural mortality, which is age-specific based on the Lorenzen model. And like the Alabama model, we used the Age Structured Assessment Program, or ASAP, from the NOAA Fisheries Toolbox. We assume 3 fleets in the model, and fleets are just the convenient way to organize fisheries-dependent sources of removals. We had a commercial fleet, which included landings and dead gillnet discards. So we estimated our gillnet discards and then applied a mortality rate, the number which I cannot remember right now. Hopefully Mike and Ann can help me out if you need that specific value. And then this commercial fleet, this includes your gillnet, pound net, gigs, trawls, and all other kinds of commercial gears, except for the commercial shrimp trawl, which we included as a bycatch only fleet. And again, but we assumed 100% mortality here. We assumed those were all dead. And then our third and final fleet is the recreational fleet. And this is harvest and dead releases. Again, from that estimate of total released alive, we assumed a mortality rate and input those dead discards. And this included hook and line, and both hook and line and gig catches. Excuse me. So here we have our time series of total landings and discards for the South Atlantic, from North Carolina to the east coast of Florida, in units of metric tons, I think. And you can see that shrimp trawl discards are very minor, but we did include them. Again, those are dead discards. And there's a slight declining trend over time in the commercial, and recreational is sort of up and down, but it has been increased in more recent years. We included 8 fisheries independent surveys. We evaluated a ton. We have a process. Our stock assessment process is a series of workshops. We start with the planning workshop, then we have the data workshop, and this is where we evaluated all the available fisheries independent surveys. And we just had a time trying to decide what we were going to incorporate. And so what we decided on is we would include 1 adult and 1 juvenile or recruitment survey from each state, if available. And so this is what we did, except for Georgia, because Georgia didn't have a juvenile survey. And the recruitment is representing age 1 fish, because that's how the ASAP model works. The youngest age it handles is age 1. It doesn't do age 0, like, say, other models like stock synthesis. And then the adult surveys were representing age 2 and up. And finally, we also had 1 ocean survey, CMAP, which had both age 1 and 2 and up. This map just gives you an idea of the coverage of all the different surveys that we use. So both the green and the red dots, just to show you that we're covering a large portion of the stock area. So I'm going to go through our indices. In North Carolina, we were able to develop both a juvenile and adult index. The juvenile index was derived from a shallow water trawl survey. It's also known as Program 120 for those of you who are familiar with our program numbers. And you can see it's variable with a declining trend in the final years of the time series, but a possible positive bump in the very last year. The adult survey was derived from our Pamlico Sound Gillnet Pamlico Sound Gillnet survey, or Program 915. It's a shorter time series, again variable with a declining trend in the last few years of the time series. In South Carolina, like North Carolina, we were able to develop both a juvenile and adult index. The juvenile index was developed from an electrofishing survey, which samples in lower salinity waters. And you can see that in the more recent years, the relative abundance is much lower than it was in earlier years. The adult index of relative abundance was developed from a TramelNet survey, which samples in higher salinity waters. And that one, I think the declining trend over time is very apparent. As I mentioned earlier, there's not a juvenile survey available for Georgia, but we were able to develop an adult index from their ecological monitoring trawl survey. And this one is very variable. You can see there's a few years missing. I think that was due to funding limitations, but there's really no overall obvious trend in this survey. And finally, in Florida, they have a trawl survey that samples throughout the state, and we developed both the juvenile and adult index from this survey using a size cutoff. Oh, sorry, I said finally. I forgot about CMAP. So CMAP is our ocean survey that samples in the coastal zone from Cape Hatteras down to Cape Canaveral. And this index shows the most promising trend in recent years, with an increase from about 2013 through the terminal year. But again, like the other ones, it's just so highly variable. Now I'm going to get into the model results. I'll jump into predicted recruitment. Again, recruitment is defined as age 1 fish. And you can see, so we have recruitment in units of thousands of fish on the y-axis, time on the x-axis. The blue dots in line represent the recruitment estimates from the model, and the lighter colored dotted lines, I believe that's plus or minus 2 standard deviations of those estimates. And you can see a declining trend over the time series. Female spawning stock biomass is shown here. This is your mature portion of the stock. Again, we have the light dotted lines representing the uncertainty about the point estimates, which are shown in blue. And you can see that there's not much trend in the early part of the time series. I'm having trouble with this. But in the last decade or so, there's a declining trend in female spawning stock biomass. This is a bubble plot of the numbers at age, where the bubbles are proportional in magnitude to the numbers at age in a particular year. And you can see, you can follow some of the cohorts through this over the time series. But what you want to get from this is that the stock the majority of the stock is made up of young fish, mostly 1 and 2 year olds. And remember that age 4 is a plus group, so anything older than age 4 is collapsed down into that age 4 group. Here is a bubble plot of catch at age, and this is total catch, so it includes commercial, the commercial fishery, the commercial shrimp trawl bycatch fishery, and the recreational landings and discards. And here you can see that the majority of the total catch is made up of 1 and 2 year olds, to a lesser degree the 3 year olds. And finally, predicted fishing mortality doesn't have much of a trend over the time series. You can see the, as what I consider pretty wide error around the estimates, but not an obvious trend. And in the final year, there's a small decrease. So for defining reference points, we sort of followed the North Carolina model, where we define a stock size reference point and a fishing mortality reference point. For stock size, we chose to define it in terms of female spawning stock biomass. Fishing mortality is just fishing mortality. And we usually, when we can, define 2 reference points, a target and a threshold. And the threshold is what determines the stock status, whether or not it's overfished or overfishing is occurring. And I'll talk more about that in the next slide. But our reference points are also defined in terms of SPR, spawnal potential ratio, and we have For our targets, we're using 35%. So that's 35% spawning potential ratio with respect to the virgin or unfished stock. And then our threshold is determined in terms of 25% SPO. So for determining stock status, if the current stock size is less than the threshold for our female spawning stock biomass, then the stock is overfished. For fishing mortality, if current F, or F in 2017, is greater than the threshold, then overfishing is occurring. I'm going to go a little faster. I'm getting the warning sign here. So here again, we have our estimates of female spawning stock biomass from the model in the open circles. The solid black line is our threshold, and the dashed line is our target. And the threshold, again, is what determines whether or not the stock is overfished. And you can see that and you want to compare 2017 to the threshold, you can see obviously it's below. It is for the entire time series, so we can say that the stock is overfished in 2017. For those who are interested in numbers, they're shown here. As I said, the stock is overfished because the estimate in 2017 is below the threshold. Fishing mortality, the graph is similar. We have the estimates from the ASAP model shown in the open circles over time compared to the threshold shown in the solid black line. Oops, sorry to control this. And then the target in the dashed line. And you can see in 2017 that our estimate of fishing mortality is above our threshold. So that means that overfishing is occurring in 2017. Again, the numbers are shown here for those of you who are interested in that. As I said, overfishing is occurring because our final year estimate of fishing mortality is higher than our defined threshold. Okay, so stock status as of 2017, we're seeing a larger proportion of immature fish in our landings. We're seeing fewer and fewer fish in the age 4 and up. There's no evidence of recent high recruitment. Recruitment's been predicted and observed recruitment's been declining in recent years. Over the past 10 years, fishing mortality has been, it's not much trend, but it is more increasing than decreasing, and female spawning stock biomass has been decreasing. And this, I really like this plot just to illustrate what's going on. So this is length at age for 5-year increments. And you can see that, you know, in the early years, so in the early 2000s, there were many more fish age 4 and up. But as we come down here to the more recent time series, they're just not seeing them anymore. And they're also getting, the lengths at ages are also getting smaller. So you're seeing fewer larger fish. These are what we consider the high priority research recommendations. If you're interested in all the research recommendations, they're listed in the stock assessment report, which I'm happy to share with anyone. But these specific research recommendations are those that the peer review panel felt were the most important for improving the reliability of future assessments. So just let you read those there. I think that's my last slide. Okay, and with that, I'm happy to take your questions. Or Mike and Ann are happy to take your question.
I think actually we might just need to wait till the break for
sorry.
questions. We're pushing up against the edge of the next one. Thank you, Laura.
Yeah, thank you, Laura. Next talk is by Kenneth Erickson, who's going to tell us about his work on climate change or changing climate associated with the decline in southern flounder.
Thanks, Steve. So today I'm going to be talking a little bit about my work that I completed while I was here at Louisiana State University in Baton Rouge, looking at how a changing climate might be impacting the range-wide decline of southern flounder. Before I get started, I'd just like to thank all the folks who made this research possible, including Steve and Mike at LSU, Louisiana Sea Grant, all the folks at the Louisiana Department of Wildlife and Fisheries, as well as all of our state agency and academic institution partners below. So, of course, today I'm going to be talking about southern flounder, and so I know that you all know the background on the fish clearly, but just want to highlight a couple of things to keep in mind throughout the presentation. First, obviously, this is a species with a large range. It's present in both the Atlantic and the Gulf of Mexico. They have an estuarine-dependent life cycle. So as has been mentioned, they move into the estuaries where they grow, mature before they move back offshore to spawn. And during that time period, physical transport, things like wind direction, tides, currents, are very important to get these juvenile flounder into the estuaries to recruit. And then finally, southern flounder exhibits sexually dimorphic growth, where the females are growing to be much larger than the males, and as a result, comprise most of the fishery. Again, most of what we've heard today. About the time I got to LSU, we had these dreams of catching boats and coolers full of flounder and doing a big project on them. But what we found is that in places like Alabama, North Carolina, South Carolina, and in Texas, the public and the anglers were noticing that something were wrong with southern flounder. They just weren't as many as they thought there should be. They weren't where they used to be. And state agencies have seen similar things. As we heard from Dr. Farmer and Erik earlier, fishery independent sampling surveys are just not turning up a whole lot of flounder. And the Louisiana Department of Wildlife and Fisheries' most recent stock assessment found that there's an alarming rapid downward trend in spawning stock biomass. And same thing in the flower stock assessment for the Atlantic Basin. They found that the probability that the spawning stock biomass to be below the target and threshold value to be 100%. And this has resulted in some drastic management measures, including North Carolina actually had to close both their commercial and recreational fisheries in 2019. So to get at this, we really wanted to get an idea of what was happening. We were hearing these reports and hearing from different agencies and places throughout their range that something was wrong, but we really wanted to try to put together a big picture. So to start, we first had to quantify the trends and see what was actually happening throughout the range. And then we picked 3 lenses through which to look at the problem. The first of spatial synchrony, are similar things happening in areas that are closer to each other? Secondly, environmental correlates, how is that changing climate impacting these fish? And then finally, we got into this idea of environmental sex determination. How could that changing climate actually be influencing the biology of southern flounder? But before we could look at those bottom 3, we actually had to quantify the trends that were happening. So to do this, we were able to obtain young of year sampling fishery independent sampling data from 6 states in the Gulf of Mexico and the Atlantic. And you can see that we were able to get some of those longer time series from states in the order of 30, 40 years in some cases. And while we mostly went with the trawl survey gears, there were a few instances where we were given data with one gear type, or the state agency, just due to the different sampling designs, recommended another type of gear to use. So there are a few differences in there. We then broke that state level data down by estuary so that we could get a more fine scale view of these trends and what was happening with southern flounder. And that gave us 31 estuaries throughout the Gulf of Mexico and the Atlantic Basin to look at. To fit this data, we selected generalized additive models to evaluate the data, and we did this for 3 primary reasons. One, as has been mentioned, we figured we were going to get a whole bunch of fishery independent samples that caught 0 southern flounder, and we needed a model that could handle those. We also were expecting that different estuaries would have different trends, so we needed one model that was flexible enough to fit different shapes of data. And then finally, we weren't as interested in the year-to-year variability, but rather the more longer-term average trends. And you can see in that figure on the left, if you just simulate some data, how a GAM really smooths through that information. We used a negative binomial distribution and used restricted maximum likelihood to select our knots, which you can think of as the number of segments or how flexible the line is to the data. And what we found are plots like these, and I'll show you our full complement of results here in a minute, but I just want to walk you through these. We'll label each of the estuaries at the top, and then on the y-axis is the catch per unit effort, or those young of year flounder per sampling event, with the years on the x-axis. Each state will have a different color line, and then you'll primarily see these 2 types of trends, these more cyclical trends like we saw in Calcasieu, and then other trends that are more one direction, like in Lower Laguna Madre, Texas. And we also have highlighted the last 5 years of data for each area, just because that's the time when we were seeing these articles and these reports from agencies about recent concern with southern flounder. So to help us zoom in and see what's happening in those last 5 years. And what we see here in the Gulf of Mexico is that almost throughout all of the estuaries here, we're seeing declines. and these are occurring on the long-term scale, but also if you zoom in on those red shaded areas, you're seeing recent declines happening within the last 5 years of data with southern flounder recruitment. So certainly a cause for concern there. And same thing when we move to the estuaries in the Atlantic Basin, you're seeing both long and short-term declines in southern flounder from these fishery independent sample surveys. So having quantified the trends and showed that there's obviously a range-wide concern for this species, we next wanted to look at spatial synchrony. And synchrony, if you're not familiar with it, is basically comparing how trends match up with each other. So you can have examples of positive synchrony, like in the top two examples where trends are moving in the same direction. You can have negative synchrony where they're doing opposite things. As one goes up, the other goes down. And you can have no synchrony where the trends just don't match up at all. So to do this, we got an annual GAM predicted value of CPUE for each of our years. We then intersected the years that each pair of estuaries had in common, and from that we got a Pearson correlation coefficient to measure synchrony. Now, when we do this for all the years that each pair of estuaries had in common, there's really not much of a trend to the synchrony. We see some negative synchrony in the red, some blue synchrony, or some positive synchrony in the blue, and then some places where there's not much synchrony at all. So our next question was, well, what if we only look at the last 5 years of data, the time period when we're hearing and seeing these declines occurring? And we did this with the understanding that anytime you reduce your sample size, you're going to inflate your correlation values. But we were more interested in how do the directions of that synchrony change. And what we see is that in the last 5 years, it's almost all positive synchrony, indicating that estuaries have trends that are moving in the same direction, which would be indicative of a range-wide decline. Now, what's interesting is that we actually compared neighboring estuaries to those that were further apart in the same basin, and we found almost no difference. So there doesn't appear to be much of a spatial explanation, but this does show that throughout the range, something is happening with these species. Something similar is happening. So having evaluated the spatial aspect, we next wanted to get into the environmental correlate aspect, because we know the impact that the environment has on the survival and the recruitment of this species. So to do this, we collected data from the National Data Buoy Center. We picked the time frame between December and April, knowing that peak recruitment can be highly variable, both by location and even just from year to year, and we wanted to make sure we captured that. And then we evaluated growing degree days, which is a measure of how much heat a fish is experienced compared to some threshold, and we tested that against 3 different temperature thresholds, as well as the summed hourly wind speeds in each of 8 directions. So similar to the Taylor paper that I think has been shown a couple of times so far today. And what we found is that in 6 of the 17 estuaries that we were able to test, and I should mention that we only did these environmental correlates for estuaries that we were able to have at least 10 consecutive years of data for. So we wanted to make sure that we had an appropriate time period. Only in 6 of those 17 were growing degree days significant. But what's interesting is that you can see the bolder colors are the significant relationships. So in Corpus Christi, Texas, and in Barataria Bay, Louisiana, you have significant positive relationships. So increased growing degree days were correlated with stronger recruitment, and those are occurring in the winter months. So it might be a little bit warmer winter helps the fish survive. But then when you get to the significant negative relationships, more growing degree days associated with less recruitment, you're seeing those happen in the later spring when it might already be warming up and potentially getting outside those fish's optimal thresholds. Now, it's a different story with wind, where we were able to evaluate 21 estuaries, and we saw a significant effect of wind on southern flounder recruitment in all 21 of those estuaries. And I'm just showing you some examples here from the Gulf of Mexico. But again, those bolded colors are the wind direction on the y-axis and the time period on the x-axis that we were able to find those significant relationships. And what's interesting is that you're not just seeing one wind direction at one time of year that's significant, but in often cases you're seeing both a positive and a negative relationship and even multiple different wind directions that can be significant in some cases. Now you might be looking at these matrices and thinking, well, what does that actually mean in practice? So as an example, I put up here a couple of our results from here in Louisiana. And what you see initially doesn't make a whole lot of sense. The directions that were positively correlated with recruitment actually appear to be pushing offshore. and the ones that are pushing alongshore in red have the negative relationships. But one thing to think about is that southern flounder aren't recruiting at the surface. They're recruiting at midwater column depths, which means they're subject to physical oceanography factors like the Coriolis effect and Ekman transport that are rotating those currents to the right of the wind direction as you go down in the water column. And so when you apply that, what you're seeing is that at the depths that these southern flounder are recruiting at, the positive directions are actually pushing the fish along the Louisiana coastline where they're more likely to encounter an inlet, be able to get into the estuary and settle, and the negative relationships are actually pushing them and preventing them from getting in as quickly. So having shown a local but heterogeneous effect of environmental correlates, finally we had this question of environmental sex determination. And this is really more of a question of, are southern flounder declining or is something actually changing? And so I'll walk you back to my introduction slide, which pointed out that southern flounder exhibit sexually dimorphic growth. It's a largely female fishery. And literature shows that the sex that southern flounder exhibit is determined between 35 and 65 millimeters total length at this critical period. And some studies have shown that at extreme temperatures, both warmer and colder, these fish appear to masculinize. So you can see two examples of studies here, where at kind of your average or moderate temperature, you have much closer to a 50-50 or what's to be expected sex ratio, but you go a few degrees warmer or a few degrees colder, and you go almost all of those males. So our question is really, if historically southern flounder have been spawning in the winter, and then they have these long periods of cool, moderate temperatures through which to hatch, grow, develop, and result in this 50-50 sex ratio, if under a changing climate scenario, these fish are still spawning in the winter, but now they're encountering warmer temperatures, and those warmer temperatures earlier, as they're developing through that critical window, it could result in populations of almost all those smaller males that you wouldn't be seeing in the fishery. Now, I wish I could stand up here and tell you that we had the sex ratio data to show that that was absolutely happening, and unfortunately, we don't, but what we wanted to get at was try to look at some areas where this could be happening. Where are these development windows getting shorter before the fish are encountering those warmer temperatures? So to do this, we took consecutive years of water temperature data. We then identified the cold fronts or rapid drops in temperature over a period of 48 hours, because that's typically associated with southern flounder leaving the estuaries to spawn. We then identified a warming threshold, or the period where those fish would encounter those warm temperatures that can masculinize, and the point at which those temperatures were reached for 10 consecutive days. So in other words, once it got warm and stayed warm. And then we measured the period between the second cold front, assuming not all fish are going to leave to spawn at the first, but all the ones that are going to spawn will likely have left by the last one, and the warming period as our development window. And we wanted to see if this was shrinking. And in somewhere like Apalachicola, Florida, this window has closed by almost 30 days since the mid-1990s, meaning that these fish are now encountering a longer period of warm temperatures that could masculinize the population. In Pamlico Sound, North Carolina, this is even more pronounced, almost 60 days since the early 2000s, those estuary waters have warmed. And overall, we were able to get water temperature data to do this for 12 estuaries, and we found this window to be closing in 7 of those, but you can see that it was in 7 estuaries throughout the entire range, indicating that there certainly could be something happening range-wide here that's closing that development window and could masculinize the population. So with that, we successfully quantified the trends and then looked at it through 3 different angles, and I just want to leave you all with a few conclusions. First is that widespread declines in southern flounder are occurring in both basins. Secondly, estuaries have individual dynamics, but there does appear to be recent range-wide synchrony in the trends. Third, environmental effects are local and heterogeneous, but it certainly does appear that wind and physical transport have a large role to play. And finally, this idea of a closing window of the role of environmental sex determination could be one of the next hypotheses for disappearing biomass. That's all that I have, but I'd be more than happy to answer any questions if there's time. Thank you.
We do have time. You nailed that perfectly. All right. Nancy.
Hey, Nancy Brown Peterson, Southern Miss. So this is pretty cool. Are they extending their range? Are we getting these things up in Virginia, the Bay, up through the Mid-Atlantic? I mean, that would be the obvious thing that should happen if they need that temperature. Any data for that at all?
Right. So we did not look much at range shift or habitat expansion. That was not within the scope of our project. I haven't heard of them making much of a push further north, but again, that would just be anecdotal from me. Yeah.
I also think that maybe summer flounder are moving north a little further. I can't remember where I read that, but if this is true, maybe for southern flounder, it could happen, perhaps.
Yeah, it's certainly something I think fishery managers and folks will be keeping an eye on over the coming years for sure. Think of another one.
Yeah, Fred Scharf, North Carolina again. So Kenneth, I noticed in the spatial synchrony that you looked at the whole time series and then the most recent, and that positive spatial synchrony increased, but there were a few clear examples that there was negative synchrony, right? So
there were,
and there was a few of those locations that must have been showing positive trends. So did you look at those at all just to kind of see what might be going on in those systems that produce positive juvenile catches?
It's a good question, and we didn't really dig down into that, but you did catch on that those, the ones that are showing that negative synchrony were where there have been increases over that last 5-year period. So I believe at least from our data in Charleston and Upper Laguna Madre, Texas, I think are the two that have seen little increases. Of course, over the long term, I think they're still moving downward, but yeah, that's where the negative synchrony values came from. And it would be interesting to take a look and see why those might have seen a little bit of a bump recently, whether that was modeling or data or something like that.
Okay, thank you.
We have one more talk, then a break. Then we start off with the aquaculture and genetics session in the afternoon. I will mention the next two talks by Drs. Godwin and Borski are sort of the transition from some of the things we've been talking about, life history, pop dye, into more of the genetics and eventually aquaculture stuff. So these are sort of the transition talks, and looking forward to both. Dr. Godwin?
All right, see if we can master this here. All right, well, thank you. I really want to thank the organizers for the opportunity to participate, and all the speakers have come up for really beautifully setting things up. Laura and Kenneth, especially right immediately before this talk. Also acknowledge co-authors, and I'll come back and really highlight a super talented young scientist. Jamie Honeycutt here, actually Jamie Mankiewicz now, and other collaborators at NC State. So we've been working on Southern Flounder actually for some time, and I'll tell you the motivation for that. And so just since we're introducing ourselves a little bit, I'd come at this from a reproductive biology standpoint, not a fishery scientist, so please don't ask me to do any von B curves. And so I'd worked actually for my dissertation on anemone fish, male to female sex changers, and then the bluehead wrasse, female to male sex changers for about 30 years. And so beautiful animals, so the logical next species would of course be the southern flounder. So to, again, just highlight leaders, so dissertation work is represented here, and Jamie Mankiewicz, very talented young scientist, as handy with a net in her hand as she is with a pipette in her hand, so straddles the field to molecular biology in the lab, so big shout out there to Jamie. All right, so I don't need to spend a lot of time on these introductory slides with this crowd, clearly, as we've gone over this and had updates. We come at it, starting in the late 90s, I guess. We're interested from an aquaculture standpoint, and given the sexually dimorphic growth, there was a big interest in sex determination in the species, and there's already starting to be a lot of really interesting work on the congener from Japan, Paralichthys olivaceus. And especially with this dependence on and the larger females, this is especially crucial here. So we've had an update, and this is now actually a slightly dated slide, so thanks again, Laura, for updating us on that stock assessment. So we've been interested in sex determination processes for some time now. This is a little over a decade ago when we did this review, and led by Adam Lukenbach. And I'll just, so temperature-dependent sex determination is not uncommon in flatfishes. That's the first point here. This is actually just highlighting the data for Paralichthys olivaceus, and a lot of beautiful work done in Japan. And then we had followed this up, looking at southern flounder here. And so you can see a very similar pattern. And so just for orientation, because we'll see more of these, this is the proportion females, and then this is the rearing temperature during that temperature-sensitive period. So you can see a strong dependence. And so we saw this depicted in a different form, thank you, Kenneth, from that 2003 Lukenbach paper. All right. Do I have to hold it down? Oh, there we go. All right. So just to tell you a little bit more about the sex determination system here. This is, for somebody who works on sex determination, these animals have kind of a profoundly weird sex determination system. I like to think of it as sort of mix and match. They're a little bit sea turtle and a little bit mammal. And so what do I mean by that? It's relatively simple if they inherit what we think of as a Y or a Y chromosome, a male sex determiner. They will be male, the offspring. And so this is consistent with data we've generated and a lot of data from the Japanese flounder. And this is true regardless of marine temperature. If they don't, if they're XX, then it gets more complicated and you get environmental sex determination. And so at a moderate temperature, around 23 degrees Celsius, you get females from this genotype. But as Kenneth alluded to, in 2003 paper from Adam Lukenbach, at either lower or higher temperatures, then you get predominantly males. And this can be quite askew, especially at the higher temperatures. Okay, so Russell Borski will follow up after the break, and he'll talk more about some of what we've learned about this. But we've come to think of this as it's potentially a whole lot of different sorts of stressors, and he'll tell you about some surprising ones. And so temperature, in this sense, may represent a bit of a stressor, high temperatures. And so this is this complicated system of sex determination. So we were curious. We'd done a lot of this work in tanks, and what happens in tanks doesn't necessarily happen in nature. So we were curious about whether these animals were sensitive in this way in their natural habitat. We didn't know of any studies that suggested natural variations in the habitat could influence sex ratios. Hadn't been done in the Harami, for example. If so, this could be important for fisheries modeling. And clearly, global temperatures are rising and the ocean is warming up. So it could be important in that respect as well. So just do this quickly and want to especially acknowledge the help of North Carolina Division of Marine Fisheries, without whose help this would not have been possible. So I'm very grateful for that. We got samples from this P120 survey that was referenced earlier. Unusual year used in those. We put out temperature probes in all years and data sums in 2016. And we determined juvenile sex ratios through a gonadal biomarker approach that I'll explain in a minute. Okay, so what's the motivation for developing this gonadal biomarker approach? Is it just because we love pipetters and fancy machines? I'll say no, although I guess we probably do. So as we're familiar, the juveniles settle into these nursery habitats in the spring. Sex is determined during this window of sort of 35 to 65 millimeters, and we have some suspicions that could narrow that range. If anyone's interested, I can talk about that. So happening in the spring in North Carolina, they grow and then they'll leave for deeper water. If you want to do it, sex the animals either histologically or visually, you have to wait until they're quite a bit larger, about 120 millimeters plus. And by that point, they've left the habitat that determined their sex. So we wanted to come up with a method where we might be able to find out what those environmental influences were while they were still in the habitat, where those influences were having their effect. I'll just point out here that this can be quite handy if people aren't familiar. There is a difference in shape in the gonads, and it's pretty accurate. So we did some validation work on that. So with the females being sort of more elongate and triangular, and the males being more rounded there. So could we find out what sex they were becoming while that was happening? So hence the reason for these gonadal biomarkers, and these are gene expression markers in the gonads themselves. And so the first of these we developed was this P450 aromatase. And in case you're fearful that I'm going to go into steroid biochemistry now, fear not. The key thing to remember here is this is the critical and rate-limiting enzyme for estrogen synthesis. If they don't make aromatase, they don't make estrogen, they don't become females. A second one across vertebrates is this transcription factor, FOXL2, and this actually drives aromatase expression. So pretty much across vertebrate animals, this is just a nice marker for female determination. And then there's a male marker we developed, Malarian inhibiting substance, or MIS. So male and female markers. If you want to know more about how we did that and the validation of these, you can look in these papers here. Okay, so this is just what these data look like. Females, so this is plotting MIS expression against FOXL2 or aromatase expression. So females have high FOXL2 and aromatase and low MIS, so they're low on this scale. Males are the opposite. In some cases, these juveniles had low expression of both, and these were undetermined. So these are the sampling locations, again, that NCDMF samples, and so we got samples from those surveys, incredibly helpful again. We looked at the North region, all within North Carolina, and keep an eye on these colors because I'll use them again. So the Pamlico in the north, the Neuse River drainage in the middle of the state, and then south of the New River for the southern part of the state. Oops. Okay. Okay, just really quickly, we did pretty simple for the temperature stuff, just eye buttons, recording every 2 hours, and we put them on these PVC pipes. And then we tested them for hurricane durability. We didn't want to, but we did, and they lasted through a hurricane. And we also did data sondes 1 year for oxygen sensing. And if you've done those with oxygen sensing, you probably know why we didn't do them in other years. So this is just an example temperature record with the blue northern region shown here in the sort of blue-purple, the southern region shown in these red traces, and then the middle region shown in green. And so you can see this variability from sort of week to week, but pretty consistent variation between north and south. This is just what it looked like over the 4 years that we had these data. So pretty consistent differences between these different parts of the state. This just looked at in a different way with these average temperatures for 2015 through 2017. And the key point is there's about a 3.5 degree difference between the northern regions here and the southern regions, especially south of the New River. So sort of keep that temperature difference in mind. So did they differ in the sex ratios that we found using these biomarkers? And the answer is yes. And so across all 4 years of these studies, you'll see we find pretty close to 50-50 sex ratios up in the northern Pamlico sampling sites. Very heavily male bias sex ratios here in the south, so males shown in the clear part of these bars and females in hatched portions, up to 94% actually in 1 year of the study. So these are juveniles, and so does this translate into adults? And that's an open question. But so we found some pretty significant differences between these sites associated with the differences in temperature. So this is a correlation clearly. A lot of different things could be differing between these habitats. And so what we wanted to do is try and isolate temperature in tank trials, so in a controlled laboratory setting. And so we took as our base profile this one from a Swan Quarter Bay in the Pamlico, averaged about 23.2 Celsius. And so we used that as a starting point. And what we wanted to do then was take that same general profile with fluctuating temperatures and mimic 27 degrees Celsius. And then also, because we'd seen these cool temperature effects in previous studies, also drop it down to about 19. And basically ask, could we recapitulate what we saw in the wild when in these controlled tank trials? So the answer is yes, that's what we found. So here is that 23 degrees Celsius, that's a little male biased, but you can see that either the fluctuating or the constant 27 degree Celsius treatment produce extreme male biases in these juveniles, and we're much closer to 1-to-1 at 23, with 19 degrees also producing a male bias there. I'm just going to skip past this slide because this is easier to see. So this is the laboratory trial, and I've got the regions that this is meant to mimic, color-coded here. And then you can see the data plotted across the years of the study here on the right. So we feel like we did actually a pretty good job in mimicking what we saw in the wild. So that gave us confidence that temperature was indeed probably it could certainly be an important factor here. So just by way of conclusions, just recap a little bit what I said. So sex determination is quite sensitive during a temperature-sensitive window, and this critical window of development in southern flounder. Field studies indicate that you find these both habitat and interannual variations in temperature, especially across these different habitats and latitudes in North Carolina. And this is associated with differences in sex ratios. When we mimicked these temperature differences in the laboratory, we were able to essentially recapitulate much of what we saw in terms of the differences between sampling regions and nature. And as far as we knew, these are the first studies that suggested that environmental sex determination could be affecting this important demographic parameters in a wild population of an important fishery species. Just in terms of implications, we'd like to extend this. We don't yet know, I don't think. We haven't sort of closed the loop to show this translates into effects in the adult population, but I think that would be important to do. But if so, this may be important to consider in modeling efforts. Clearly, the latest IPCC, I think, projects an increase in sea surface temperature of about 0.18 degrees Celsius per decade in this century. And again, in a fishery that's heavily dependent on females and where you've got this temperature sensitivity, this clearly could be quite important. So I'll just close with some acknowledgments to a whole lot of folks, including sampling help I mentioned, NCDMF, a lot of help with fish care, a lot of folks in Russell Borsey's lab and my laboratory, and then, of course, funding sources, and be happy to take any questions. Thank you.
This is Paul with Parks and Wildlife, Texas Parks and Wildlife. I was wondering if you're familiar with some of the work that's come out of UTMSI that shows a lower temperature for the 1-to-1 sex ratio for Texas fish, and if you're familiar with that, can you comment on that?
Yeah, no, thanks for mentioning that. And so there was a 2012 paper from Joan Holt's lab. Montalvo was the first author, if people are familiar, interested. And so it shows an overall regression. I guess, so correct me if I'm wrong, so it was pretty similar, sort of 18, 19 degrees and 23 degrees there. But my recollection is they used a regression analysis. It wasn't clear to me that you actually got more females at lower temperature, but it's clearly possible, I think. You've got these genetic differences between basins, given the different timing for spawning and the temperatures that they may be experiencing in the nursery habitats. I think that sort of latitudinal variation is, I mean, it's not only possible, it might be likely, because in snapping turtles and other species, you see that sort of thing, differences in pivotal temperature. So I think it's the kind of thing that would be great to get more information on. Also, I should, if I could just quickly acknowledge, they also did a nice job with us, basically a temperature shift experiment to define that 35 to 65 millimeter window. So.
And do you think any of the parameters specifically temperature before that window, does that have an effect on them, or does nothing matter until they reach that 35 to 65 millimeter window?
I don't think we have any information that bears on that. Are you familiar with any, Russell? Yeah, I don't think we know. Yeah, it's a great question, though.
Thank you.
Hi, it's Nancy. So I might have missed this, but what size are the fish when you're doing the molecular, determination, and are there any gonads? So can you actually visually see a gonad in a, like 100 millimeter fish or something like that?
I'm not sure I can see them, but Jamie can. They are very tiny, and it takes real skill to dissect those out. And in answer to the first part of your question, is there were a range of sizes, actually starting with some fish in the 50 millimeter range and on up into sort of 90 or 100. But yeah, so I certainly wouldn't minimize the difficulty, but they're there, and yeah. So does that answer your question? Okay.
Great talk, thank you. In the context of maybe other species that we have looked at in terms of environmental sex determination, and we have more data on, is there any evidence that in our case, the parabolic sort of mid versus extremes is conserved over latitude or over space, but shifts with the temperature range? And I'm thinking about extremes in North Carolina may not be extreme temperatures, absolute temperatures in Texas, but yet would that overall pattern be conserved, just shifted to warmer temperatures?
So the best data are from reptiles, and they don't show that same sort of parabolic curve. And the ones I'm familiar with that have a similar sort of temperature response haven't really been investigated from the latitudinal. Snapping turtles, for example, are really well studied in this respect. I would say the closest we can come, other than some failed experiments we did, I don't remember which hurricane it was that took out the latitudinal variation experiment we tried one time, Russell, but might be the difference. There's certainly a suggested difference between the Japanese flounder and the southern flounder, and if you compare the temperatures when they're developing it, they're about what you'd predict. So it's a little bit cooler where the harami are developing. But beyond that, I think it's the kind of thing that would really benefit from careful study. So.
Thanks, John. Nice talk. Just curious if you could talk about kind of the next generation consequences, especially thinking about all these propagation efforts that are getting underway for southern flounder. If you're using sex-reversed females in propagation, potentially XX, what are the kind of down the road consequences of that, potentially positive or negative for maybe stocking programs?
I mean, the most maybe immediately apparent one is it's going to restrict when you can do your stocking, unless you want to grow the fish out to a size at which they're no longer affected by temperature, which I don't think probably fits well under anybody's. I don't know if anybody has facilities for that, temperature-controlled facilities to raise millions of fish. So I think that's one immediate impact there. So that, yeah, it's probably restrictive in terms of the seasons that you can do it. Gosh, other ones, I mean, I think there's probably, from a stock enhancement standpoint, you probably don't want to mess with the wild genotype composition. It becomes potentially really valuable in aquaculture. And so I think there's a number of questions that we probably still need to answer. So we don't know, for example, if you get a warm spell, are they essentially irreversibly altered? Is it a short-term thing that can happen, or are they integrating over a longer period? I think we don't know what the sequence is. We may get females essentially as the first fish in a given habitat, and males are coming out of it later. That would be consistent with Atlantic silversides, which nobody eats, but they're really well studied from a TSD standpoint.